Data analysis can play a pivotal role in business decisions and processes. In order to use the data to make confident decisions, we must have the right information for the project and the data must be free from errors. In this video, we will learn how to profile data to discover inconsistencies. Whether we are working with small sets of data or analyzing a spreadsheet with thousands of rows, one of the most difficult parts of the data analysis is finding and keeping clean data. To help with this process and qualify the data, look at these 5 traits: accuracy, completeness, reliability, relevance, and timeliness. Accuracy is the first and most significant aspect to data quality. A data analyst must clean the dataset by removing duplicates, correcting formatting errors, and removing blank rows. Another important aspect of data quality is determining if the information required to complete the dataset is readily available. Why does this matter as a trait for quality data? Let's say we are given the task to calculate the revenues of all sales per region. After collecting the data, we discovered that no regions were specified. This data would then be considered incomplete, and other sources would have to be considered to obtain the data required. Reliability is another vital factor in determining the quality of data. For instance, let's say we are given the task to determine the agent revenue by customer. When gathering the data, we find that agents keep their own records and do not always update the information in the shared company database. With those factors in mind, we would then determine that the data in the shared company database was unreliable, and new processes would need to be established to ensure reliable data. Relevance is another trait of quality data. When collecting information, a data analyst must consider if the data being assembled is really necessary for the project. For example, when reviewing the data related to the sales revenue per customer, information such as customer birthdays and other personal information is also included. By making the determination early to exclude the personal information from the dataset, the analyst would save themselves from having to review unnecessary information. The last factor in determining the quality of the data is timeliness. This trait refers to the availability and accessibility of the selected data. Let's say our sales report is going to be used for weekly employee reviews, but our report is only refreshed once a month. This error in refreshing the data would cause our report to become outdated and would have serious consequences for employee reviews. In this video, we learn the important role of a data analyst in qualifying data. By considering the 5 traits of good quality data, an analyst can save time, avoid serious issues, and have data that is free from errors. In the next video, we will take the collected data and learn how to import it to our spreadsheet. Now that you have learned about the importance of data quality, in this video you will learn how to import data from a text file using the text import wizard, learn how to adjust column widths, and learn how to add and remove columns and rows. As you know, by default, Excel works with .xlsx or .xls files and opens them as workbooks. But Excel can also use data that is in other formats, such as plain text or data that has been comma separated and tab separated. Sometimes these source files will be saved with a .txt extension and referred to as text files, but others might be saved with a .csv file extension and are typically referred to as CSV files. Here in Notepad, I have opened a text file that contains data about car sales, and it uses comma-separated values, or CSVs, to separate each bit of data in a record. Notice that the top line holds headings, such as manufacturer, model, engine size, and so on, and each one is separated by a comma. We want these to become our headers when we import the file into Excel. The line below these headings is the first line of real data, and again, you can see that each piece of data is also separated by a comma. There are 16 headings, and there are also 16 pieces of data on each of the lines below the headings. If we scroll to the bottom, we can see that last data record is for the Volvo S80. Now, to open the file in Excel, we choose File, Open, and then either select the file from the recently used list or click Browse to find the file we want to import. When we open the file, the text import wizard launches automatically, and it will start to try and determine what your file is. Note that it has been detected as being a delimited file, that is, one that has its data fields separated by a character such as a comma or a tab. As we want the headings to become headers in Excel, we need to ensure that we select the option My Data Has Headers. We can see a mini preview of the data in the preview box below. Then we click Next to proceed in the wizard. In step 2 of the wizard, we need to select our delimiter, that is, which character is separating our pieces of data, so we select comma and deselect any others. Note the data preview now starts to show us what the imported data will look like. You can scroll down and across this preview window to ensure that the data is going to look as you want and expect. It all looks okay, so we'll continue with the wizard. In step 3 of the wizard, we can set the data format for each column. For example, you might want to change a column to text or date format. In this case, we can just accept the default general format and finish the import wizard. In Excel, we can see that the headings in the text file have been imported as a header row. But also notice that some of the columns are not showing all the data. Some of the headings are not showing in full, and some of the data is not shown either. All you can see are a number of hashes in the cells. This is because the column widths are too narrow in some cases. If you remember, you can manually adjust a column's width by dragging the divider across, but to change them all in one go, we select all the columns first, then double-click one of the selected column dividers. We can also do a similar thing with rows by dragging them to make them bigger or smaller, or double-clicking a row divider to auto-size it. There are some columns that we have decided we don't really need, namely vehicle type and latest launch. So let's remove those. This can either be done using the Delete drop-down menu in the Cells group on the Home tab and select Delete Sheet Columns, or by selecting and right-clicking a column and deleting it that way. To add another column, you simply select the column to the right of where you want your new column to be. Then right-click the column and choose Insert. And let's give the header a name, such as Year. To delete a row you don't need, select the row, right-click it, and choose Delete. And to add a row, select the row below the place you want to add your new row, right-click the row, and choose Insert. If you want to save the file as an Excel file, you can either choose File, Save As, or you can click Save As in the yellow tooltip that appeared at the top of the worksheet when we imported the file. Then you would choose Excel Workbook or .xlsx in the Save As type box. In this video, we learned how to import data using the Text Import Wizard. We learned how to adjust column widths, and we learned how to add and remove columns and rows. In the next video, we will discuss the importance of data privacy, including sensitive information and personally identifiable data. In this video, we will learn about data privacy and the regulations that govern the collected data. When collecting customer data, specific regulations apply to how that data can be used. By understanding data privacy regulations and getting familiar with the following 3 fundamentals, you can eliminate the risk of financial penalties and keep the trust of your customers. Confidentiality, collection and use, compliance. Confidentiality is an important element in data privacy, and it acknowledges that the customer's personal information belongs to them. The types of information that can be accessed by a data analyst can range from sales forecasts to employee information, or even patient records. When accessing these types of records, the analyst must be able to recognize the different types of personal data. Personal information, or PI, is any type of information that can be traced back to a specific individual. This type of information can include anything from emails to images. Personally identifiable information, or PII, is specific information that could be used to identify an individual. This type of information could include a social security number or a driver's license number. And lastly, sensitive personal information, or SPI, may not necessarily identify a specific individual, but contains private information that needs to be protected because, if made public, it could possibly be used to harm the individual. This type of information can include data about race, sexual orientation, biometric, or genetic information. By understanding personal data and the associated regulations, we can efficiently anonymize our data by removing unnecessary information. This type of action can help build customer confidence and continue to develop the free flow of information. When searching through data, the analyst must know the location of the company collecting the data and the location of the respondent. Knowing where the data was collected is an essential element of data privacy and what regulations must be applied. The General Data Protection Regulation, or GDPR, is a regulation specific to the European Union and only applies to the jurisdiction of the individual. A new law created in Brazil, called the LGPD, will take effect in August 2020. These new data policy regulations apply to individuals within Brazil and ignores the location of the data processor. While the United States does not have one countrywide principal law for data privacy, because of this, individual states began to make their own regulations. For instance, California created the California Consumer Privacy Act, or CCPA, to better protect customer data. There are also industry-specific regulations that govern the collection and use of sensitive and personal data. For example, in healthcare, HIPAA, or HIPAA, privacy rules govern the collection and disclosure of protected health information. In retail, the PCI standards govern credit card data, and failure to safeguard cardholder information can result in hefty fines. With a basic understanding of these policies, we are able to remain compliant when handling any sensitive information. Unfortunately, breaches in customer data is an all too common occurrence, and understanding how to remain compliant is essential. Understanding the data privacy regulations of the European Union, the United States, and other countries as well as industries is key to keeping data safe. Companies must comply with these privacy regulations at all times, and also make sure policies are readily accessible to employees. For example, let's say a data analyst downloads a spreadsheet of sensitive information. In order to complete the report by Monday morning, the analyst decided to take their work laptop home for the weekend. After driving home, the analyst accidentally left the laptop in their car. The next morning, they found their car had been stolen along with the laptop. Because it is the responsibility of the company to keep customer data safe, this was a breach of privacy when the data left the company property. This type of action could not only cost the company large amounts of money in fines and penalties, but could also reduce customer confidence, causing a significant impact to revenue. While data privacy applies to most data that is collected, there are some instances where these regulations do not apply. In order for these laws and regulations not to apply, the particular collection of data must be completely anonymous. To make data anonymous means to exclude all data which ties it back to a particular individual. While this approach might not be practical in all circumstances, collecting data with privacy in mind could remove privacy limitations and make data collections more accessible. In this video, we learned about the importance of data privacy and the challenges that a data analyst can face when collecting and sorting through data. In the videos in the next lesson, we will learn about different methods for cleaning data in a spreadsheet. In this video, we will listen to several data professionals discuss the importance of data quality and data privacy as they relate to data analysis. Let us start with what is the importance of data quality as it relates to data analysis.
Data quality is of the utmost importance in terms of data and analytics. And the reason behind this is because as soon as what you're presenting does not align with what someone expects, that's the first thing that they tend to go after. Where did you get the data? What's happened to the data? How has it been transformed? Because people like to think that they know and understand their business. And when you start to challenge that, if you don't have the ground to stand on of the data, that it's quality, that it's clean, and that it is from a trusted source, that's when you start to get into a lot of discussions, a lot of debate, and ultimately the plot of what you're trying to present gets lost.
The backbone of any successful data analysis project is good quality data. There's a common term in computer science called garbage in, garbage out, which is essentially if you read in bad quality data, you can expect to get bad quality results. So there's really nothing more important when doing a data analysis than making sure that you're working with good quality data. And it's really important to sense check the data yourself and really feel comfortable that the data you're using is of a really high quality.
Data accuracy is above all garbage in, garbage out. It's a waste of time to analyze data of poor quality, and it might mislead the business direction.
The integrity of the data that you're using or providing for someone else to use is of the utmost importance. Data is used to determine when or where to launch a product, if a division is profitable or not, and it's easy to get things confused if you're not paying attention to the details. Using inventory as an example, if you're looking at inventory at a SKU level and you accidentally pick the wrong SKU to analyze, and then you draw these conclusions that this particular item isn't profitable when in fact it is. So that's a major decision for a company to make, obviously. So the expectation is that there will be lots of due diligence, but in the beginning, if you start off with bad data and then you build on that only to later realize that it wasn't a good idea, you've lost time, energy, effort, and in some cases, trust.
Thank you for those viewpoints. What about the importance of data privacy as it relates to data analysis?
Data privacy is incredibly important, especially when you're working in industries like pharmaceuticals or healthcare. But that's not where it stops. We have to have the ability to make sure that the users are getting the appropriate level of data based on their roles and their permissions. Now we can do this through a number of cuts of the data specific to each geography or each function, or in some tools such as Cognitive Analytics, we can start to build out that as part of our model. Within there, you can say who has access to what, whether it's at a granular level of this person can see data in Canada or the US, or whether it's simply this person can see this report in its entirety or not. There's lots of different ways to handle this, but data privacy is of the utmost importance across all industries.
In today's world, data privacy is a huge thing. On the tax side, especially of our business, we have what we call PII, personal identifiable information. We have to protect that, and so we can't just send things through email. We don't send tax returns, or even actually in our business period, we don't send things through email that have sensitive PII data in it. We encrypt it. We make sure the email is encrypted, or we use software, some certain softwares that will allow us to not show the social security numbers or the names or the date of births. And what will happen is it has a certain sequence, and we share that with the client by calling them. We don't put that in an email, and we certainly don't put that in the same email with the encrypted information, because we want to make sure that you're always safe. So we have to make sure we're protecting it at all costs.
Now that we have learned about the importance of data quality and data privacy, in this video we will learn how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. It's very common when collecting or importing data, whether through manual or automated processes, to get errors and inconsistencies in your data. This can be as simple as spelling mistakes, extra white space, or the wrong case used in text, to empty rows or missing values in your data, to inaccurate or duplicated data. Having these errors and inconsistencies in your data can lead to issues with formulas not working, with unsuccessful sorting and filtering operations, and therefore inadequately visualized and presented data findings. These data errors and inconsistencies require you to carry out some form of data cleaning routine to improve the quality and usability of the data. Let's start off with one of the easier of those tasks, which is spell checking. In Excel, this works in pretty much the same way as you may have already encountered in applications such as Microsoft Word or other common word processing applications. I have some data here relating to the sales of toy vehicles, and the first thing we need to do is select what data we wish to check for spelling. In this case, we will try column K, which contains the product line data. Then we click Spelling, which is on the Review tab. Well, that seems to be okay. So let's try the country information in column T. So we do have an error here where a country name has been misspelt, or more likely mistyped. We just click Change if we are happy with the spelling suggestion, or we could choose another suggestion from the list, or even ignore this error if we know the data is correct, but in this case, we will change it. Here's another typo for a country name, and here's one more. So that seems to be all the errors in this column. Let's try the final column now, which is the DL size in column X. Here is a misspelling of the word small, and another for medium, and that seems to be all for this column. The next inconsistency we will look for is empty rows. Empty rows in your data can cause lots of issues relating to moving around your data, working with formulas, and sorting and filtering. Therefore, it's very important to remove them from your data. If you remember from an earlier lesson, when we click Control plus down arrow, it should take us to the end of that column of data. But notice if we do that in this data set, the cursor keeps stopping when we get to an empty row, meaning that the data set is essentially being split into multiple sections, separated by these empty rows. That's not good, so let's resolve that now. We have a couple of options. One option is to just manually scroll down the sheet looking for empty rows and deleting each one, which is easy enough and fine to do if you only have a small amount of data. But imagine if you were dealing with hundreds or thousands or even tens of thousands of rows. That would be a very laborious and time-consuming process. There is a much better way, which involves selecting all our data first, either using the mouse or the Control plus Shift plus End keyboard shortcut. Then we select the filter icon on the Data tab. We can now see that each column has a filter icon next to the column header. If we then select the customer name column filter in column M, then uncheck Select All, then scroll down to the bottom of the list, we can check the item called Blanks, and then click OK. This will now show only the empty rows at the top of our sheet. This can be quite hard to see, but if you look in the row numbers, you can see that rows 28, 29, 65, 73, 74, 75, and 117 are listed at the top and are highlighted in blue text. We can now select these rows either using the mouse or going to the first cell in the first data row, which is A28, and then using the Control plus Shift plus End keyboard shortcut. Then delete the offending empty rows. We then need to clear the filter and turn it off so we can view our data again. Now, if we go back to the first row in the top of the data sheet and try the Control plus Down shortcut again to go to the end of the data column, it will work. The next inconsistency we'll look for is duplicated rows of data. It's quite common for duplicate data rows to exist in your imported data, caused either by human input error or an error in the import process. There are two ways of doing this in Excel. The first way includes reviewing the data you plan to remove first before deleting it to ensure you are deleting the right data. This is our preferred method as it provides an additional level of data security. The second method, which we will also show you, is simpler, as you don't review the data to be removed first, but it lacks the security of the first method. It's important to select a column of data that you would not expect to have duplicate values in. For example, if we consider the price each column, which is C, we would expect lots of these values to be repeated, because the unit price of some products is the same. So this is a bad example of a column to use to find duplicates. Instead, let's use the sales column in column E because it is far less likely that these values will be duplicated in the normal process of things, as they are the total sales for each order. So we select the column and choose conditional formatting, then highlight cells rules, and then duplicate values. When we click OK and scroll down the sheet, we can see that only a few values have been identified as being duplicates. There seem to be duplicate values in rows 36 to 40 and in rows 74 to 78. Let's zoom out so we can see both duplicate sections together. It seems like these are in fact exact duplicate entries and are likely to be an input error. Let's delete the second section of duplicate rows as they are out of sequence, as they relate to motorcycle sales and are in the ships section of the sheet. So that was the first and recommended method of removing duplicate rows of data, which previews the data to be removed first. Now, let's try the second, simpler but less secure method. Let's go back to 100% zoom and go back to the top of the worksheet. This time, we select the whole datasheet, and on the Data tab, we use the Remove Duplicates button. We then unselect all the columns, then only select the Sales column, and the duplicate rows are deleted. The last cleaning process we'll look at in this video is using the Find and Replace feature to repair some misspelt surnames in the Customer Contacts column. Find and Replace tools are under Find and Select on the home page in Excel. If you have used other Office products, such as Word, it should be familiar to you already. We've had an email from a Swedish customer informing us that we have her surname spelt incorrectly on her order sheets. So we type the misspelt surname into the Find What box and click Find Next. Then click it again to see there are multiple incorrect entries. If we click Find All instances are listed, and we can open the Replace tab to enter a name to replace the incorrect spellings. Her surname should be Larson with a double S, so we'll replace all instances with that corrected spelling. That looks better, and we are finished. In this video, we learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. In the next video, we will look at changing the case of text, fixing date formatting errors, and trimming white space from data. Now that we've learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated rows, in this video we'll look at changing the case of text, fixing date formatting errors, and trimming white space from data. When you collect or receive data from various sources, it's quite common to find that your data contains text in mixed case, that is, some in uppercase, some in lowercase, and some in capitalized proper case, also known as sentence case. Some of this may be intentional, but often it's not. Excel doesn't have a change case button like there is in Microsoft Word, so you need to use other methods to perform this data cleaning task. Those methods are functions, namely the upper, lower, and proper functions. You can use these functions to help you change the case of text in your data. You can see that the header row here is using all uppercase characters. So if you want to change that to use proper case, then you need to add another row to put the function in. This is referred to as a helper row. The proper function is simple to use. Just type equals, then proper, then open parenthesis, then the cell reference, in this case A1, then close parenthesis and press enter. Here you can see that the result in A2 is in proper case. Now you can try and drag the formula right across to column X by using the fill handle on A2. But this can be tricky when you have a lot of columns, so let's try another way. Instead of dragging, you can use Shift plus right arrow to select the columns across to X first. Then press F2 to bring the cursor into focus in cell A2. Then you hold down the Control key while you press Enter, and it fills across for you. You might think that you could now remove the original row, but look at what happens when you do. You get a ref error because the formula is referencing an invalid reference, and the header row cells now contain just the failed formula rather than the actual header text. So you need to undo that, and instead, you copy the contents of the helper row to row 1. But when you paste, you need to choose the Paste Values option. Now the header row cells just contain header text, and you can remove the helper row in row 2. Now let's use the upper function to change text from proper case to uppercase. Insert a column to the right of the column you want to change. This will be a helper column. Then you type the formula containing the upper function in the first data cell in this new helper column. Again, it's a simple formula. You type equals, then upper, then open parenthesis, then the cell reference, in this case T2, and then close the parenthesis and press enter. You can see the result in the country name in uppercase, and you can then copy that formula down the rest of the column by double-clicking the fill handle cross symbol. As before, you then copy and paste the contents of the helper column to the original column, but use the Paste Values option. Now you can delete the helper column. Next, we'll use the lower function to change text from proper case to lowercase. As before, you insert a column to the right of the column you want to change. This will be another helper column. Then you type the formula containing the lower function in the first data cell in the helper column. Once again, it's a very simple formula. You type equals, then lower, then open parenthesis, then the cell reference, in this case K2, and then close parenthesis and press enter. You can now see the result is the product line data in lowercase, and you can now copy the formula down to the rest of the column by double-clicking the fill handle once more. As before, you then copy and paste the contents of the helper column to the original column by ensuring you use the Paste Values option. Now you can delete the helper column. It's quite common to receive data that has a mixture of date formats, or that uses a date format that isn't suitable for your region. Now let's look at how to change the format of some dates. You can see that this date format is currently using a 2-digit day, a 2-digit month, and a 4-digit year value. When you open the number format dialog box, you can see in the locale box that this is an English or United Kingdom date format. You want to use a US date format, so you first change the locale to English, United States. In this list, you can see there are several date options to choose from. Let's choose one that uses the full month name, then a 2-digit day and a 4-digit year value. You could then copy this formula to the rest of the date cells. However, if you want to format these dates using your own custom format, you can do that too. In the number format list, you select Custom and then choose an existing format that is similar to what you want, and simply modify it to create a new custom format. Here we'll have the day, then 3-letter month, then 4-digit year. To apply that new custom date format to the rest of the column, you could either use the Format Painter tool, or you can select the rest of the column and choose the new column format from the custom list in the number format dialog box. You might find that your data has some white space, that is, unwanted spaces in your data. Here you can see that we have some spaces at the start, some spaces at the end, and some unwanted double spaces in the middle of our data. We'll first have a look at what you can do to clean up these unwanted spaces in your data by using the Find and Replace feature in Excel. So you first select all the data, then on the Home tab, you click Find and Select, then Replace. To get rid of double spaces, you enter a double space in the Find What box and a single space in the Replace With box. Then you click Find Next and choose Replace for each item you want to change. You could click Replace All to do all the fixes in one go, but unless you are absolutely sure of the changes, it's better practice to check and replace each one in sequence in case there are some valid reasons for these extra spaces. If you have a very large data set, you might also choose Replace All to save you a lot of time. So using the Find and Replace feature got rid of most of those unwanted white spaces, but not all of them. We removed double spaces using that feature, but we also have some single spaces left at the start and end of some of the cells. You can't use Find and Replace to remove single spaces. Otherwise, you would lose all spaces in your data, including standard spaces between words, which you don't want to remove. But there is another tool you can use to clear spaces from cells, and that's the trim function. To use the trim function, you once again insert a helper column. The trim function is simple to use. Just type equals, then trim, then open parenthesis, then the cell reference, in this case, M2, then close parenthesis, and press enter. You can then double-click the fill handle symbol to copy this formula down to the remainder of the column. Now, you need to copy the contents of the new column N to column M, and remember once again to paste using the Paste Values option. You can now see that those erroneous spaces have been removed, or more accurately speaking, have been trimmed. And lastly, you can remove the helper column. In this video, we learned how to change the case of text, how to change date formatting, and how to trim white space from data. In the next video, we will discuss how to use the flash fill and text to columns features in Excel to help clean data. Now that we've learned how to change the case of text, how to change date formatting, and how to trim white space from data, in this video we'll discuss how to use the flash fill and text to columns features in Excel to help clean data. We used flash fill briefly earlier in the course as a quick method of entering data that fits a specific pattern, such as the names of months or days of the week, but it can also be used as a data cleaning tool. It can split a column of full names into two separate columns for the forename and surname, and it can also help to modify the naming convention used in a column of names. For example, in the Vehicle Toy Sales worksheet, there is a column containing the last names of contacts and another containing their first names. If you want to use the flash fill feature to combine these names into one name column, you first insert a helper column. Let's call it Contact Name. Then, in the first row in the new column, you enter the full name of the first contact in the format of your choice. For example, you might want surname, then a comma, then the forename. Or you might want surname and just an initial, and so on. In this case, let's just enter the name in the standard format of forename, then surname, with a space between them, and then we press enter. Next, you'll start typing the second contact's name, and you'll see that flash fill displays a preview of the remaining names for you. If you're happy with what's in the preview, all you have to do is press enter, and it fills in the remaining names for you right down the column. It even works when there are two names in one of the columns, such as Wing C here and Dakuna here. Now you can remove the original columns if you no longer need them. So in the previous task, we saw how to combine two columns of data into one column using flash fill. Now let's see how to use it to modify the naming convention in a column. Let's switch to the Customer Contacts worksheet. Then, in the first data row of the next column, that is B2, We type the name of the first contact using whatever naming convention we want. We'll use surname, then comma, then space, then the forename, and press enter. Again, when we start typing the second contact's name in the next row down, that is B3, FlashFill detects the pattern and fills in the remaining names in column B when we press enter. You could then copy and paste the column header and delete the original column A. What we couldn't do with FlashFill was take a single column with two names in and split that into two separate columns. We need to use the text to columns feature to do that. So we'll close this worksheet and we won't save the changes. Now let's see how the text to columns feature can help with data cleaning too. As the name suggests, and unlike FlashFill, the text to columns feature can take a column containing multi-part text and split that text into one or more other columns. This can be useful for splitting any multi-part text, such as names or addresses, into separate component parts. Let's open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. If we then select the data in column A from A2 to A23, and on the Data tab click Text to Columns, a wizard is launched. On the first page of the wizard, ensure that Delimited is selected. On the second page, ensure that only space is selected as the delimiter. On the third page of the wizard, click the little arrow next to Destination and select B2 on the worksheet, then click the little arrow again to return to the wizard. We're now finished with this wizard. You can now see that the full customer contact names in column A have now been successfully split into two new columns in B and C, and you could now remove column A if you no longer need it. We'll close this worksheet, and again, we won't save the changes. You can also achieve the same result using functions. This would be required if you were using Excel for the web, the online version of Excel, as this doesn't have the text to columns feature. There's also a bit more flexibility with functions, which can be especially useful if you have names that are complex and mixed, such as having hyphenated names, or some names with a middle name, some with two middle initials, and some with no middle initial. So we open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. Next, we'll enter the formula in B2 to extract the forename part of the name. This formula extracts 5 characters from cell A2, starting from the left and including the space. Then, in cell C2, we enter the formula to extract the surname part of the name. This formula extracts 7 characters from cell A2, starting from the right. Then we'll double-click the fill handle in cell B2 to use autofill to complete the column. And we do the same to the fill handle in cell C2 to use autofill to complete that column also. In this video, we learned how to use FlashFill and text to columns features in Excel to help clean data. In this video, we will listen to several data professionals discuss issues around data quality. Can you tell us your experience with poor quality data and the cleaning of that data?
A large portion of my time is spent cleaning, verifying, checking data before I run an analysis. Working in healthcare, most of the information captured is based off of what someone's put in. So humans can't be calibrated. Two people can have a similar situation and look at things slightly differently. So it's up to me to make sure that if one describes something as navy blue and the other person describes it as dark blue, that I consolidate it and make it blue. That's just an example. We don't normally do that in healthcare. But the thought is that you always have to check the integrity of the information before you do your analysis to make sure that your results are accurate.
no data is going to be perfect. That's an unfortunate reality in the world in which we live in. Databases and data is collected for the broadest possible purpose, but oftentimes there are still things that are missing or not quite in the format that we want, whether that's collecting date and time as a single field, whereas when we're doing our analysis, we want to be able to break it out by day, month, and quarter. These are things that we can take into consideration. There's a lot of different cleansing activities that can be done and can be undertaken to help you get something that's specific and works for you and the way you want to work.
I have had experiences with poor quality data where I'm reviewing financial statements and I'm looking at margins, calculating ratios, trying to understand if what I'm looking at is, number one, directionally correct, but two, am I looking at the right thing? Are all of these costs, current costs, relevant to the period that I'm analyzing? Has all of the data been captured? Do I have all of the revenue for a given month? Then you have to go back and look at the sources, scrub that information to validate that what you're seeing is correct. And from an accounting perspective, if that data is incorrect or out of period, then adjustments need to be made to the general ledger, which houses the data to properly reflect what's happening.
Poor data quality can really come into play and cause discussions that don't need to be happening. They can cause you to be second guessed. They can cause you to not be able to be firm and present your case and your data reliably. Now, if this is the case, there's several different ways we can handle this. One is to go all the way back to the source to ensure that the source data is being pulled appropriately, or simply being able to outline and be very specific and direct in terms of what transformations or changes have been done to the data through tracking this in something like Watson Knowledge Catalog and being able to present that to your audience.
If you're filtering and sorting data and you find that it's wrong, you have to go back and fix things. That time could have been spent working on other deliverables. And again, it can call the data integrity into question if you're constantly having to redo or reiterate certain parts of data. And quite frankly, it can be frustrating at times if you're habitually having to do that. So paying attention to the details and the minutia so that you're not wasting time backtracking on something that you could have fixed early on are just some of the many benefits of ensuring that your data quality is good.
Now that we have learned how to collect and clean our data, it is time to decide the best method for analysis. In this video, we will discuss the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. Deciding how to manipulate our data can sometimes be difficult. Before we make any changes or adjustments, we will need to visualize the final output. Below are some questions to ask before beginning the task. How big is the data set? What type of filtering is required to find the necessary information? How should the data be sorted? What type of calculations are needed? Now that we have visualized the final output, we must decide the best approach to shape our data. The most basic step would be to filter and sort the data. By sorting the data, we are able to organize it based on conditions, such as alphabetically or numerically. For example, if we wanted to check for duplicate order numbers, we could sort the data and quickly see any duplicates. After sorting and removing the duplicate row, we find that the view needs to be more specific to meet our requirements. We now decide that we only want to see the data for the month of November. By adding a filter, we can now choose to only see items with a month ID that is equal to 11. By filtering our data, we are now able to only see the rows that meet the filter criteria, and it allows us to better analyze our information. Becoming familiar with all the tools to analyze data can seem daunting, but one key benefit of using a spreadsheet is the ability to use functions. Functions in Excel are organized by several categories, including mathematical, statistical, logical, financial, and date and time-based. Let's say we wanted to get an average of company revenue for the month of June. We realize there are over 100 items that would need to be calculated. In normal circumstances, to get an average, we would have to create a formula to add each row and divide by the total number of rows. This type of calculation would not only be very long, but can expose the analyst to possibly making a mistake. With the use of a function, we would be able to simplify our calculation in one easy step. Equals average, open parenthesis, B1, colon, B160, close parenthesis. While sorting and filtering data on our spreadsheet can be useful on its own, first converting your data to a table has many benefits. When we convert our data into a table, we are able to filter and calculate the data more efficiently. One example is the ability to easily calculate columns. For the column MSRP, we choose Sum, and we're able to quickly calculate the sum of the column. If we then look at the data, and we only want to calculate the MSRP total based on Japan, we would filter the country column to only display Japan, and the column would then only add the values in the rows that were associated with Japan. While all data may not work in a table, there are quite a few advantages to formatting your data as a table. Automatic calculations even when filtering. Column headings never disappear. Banded rows to make reading easier. Tables will automatically expand when adding new rows. Sometimes data needs to be more organized than what a basic tabular format can give us, and creating pivot tables with charts can be a better way to analyze and display the required information. In Excel, we have the option of creating a pivot table to display and analyze our data, and optionally, an associated pivot chart. For example, let's say we want to know what company ordered products in the month of October. From the original table of data, we create a pivot table to organize and analyze the required data, along with a pivot chart to display the information. By then adding the month filter to the newly created pivot table, we can see the results for the month of October not only in the table, but the changes are automatically updated in the pivot chart. When trying to single out specific information in a large data set, a pivot table is a nice way to show only the information that is required. This allows us to quickly and easily scan the essential information. Pivot charts are a nice accessory to pivot tables, as they allow us to visually process data and in most cases will let the audience grasp the information quicker. The advantages of selecting a pivot table and chart are manipulate data without using formulas, quickly summarize large data sets, ability to display engaging charts and graphs. In this video, we learned about the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. And we learned about some of the tools to begin analyzing our data. In the next video, we will learn more about filtering and sorting our data. In the previous video, we learned how to use the flash fill and text to columns features in Excel to help clean data. In this video, we will discuss how to filter and sort our data to enable us to control what information is displayed and how it's displayed in our worksheets. Filtering your data enables you to gain more control over which parts of your data are displayed at any given time in Excel. This can help with the visibility of data by narrowing down the data to within specified criteria and parameters, and it can also help when searching for specific pieces of data. To filter your data, the first thing you need to do is turn filtering on, which is very simple. On the Data tab, click Filter, and that's it. You will now see a small filter icon next to each of the column headers. As a side note, if you want to only filter on one or more columns, select those columns first, then click Filter. As another side note, if you format your data as a table, the columns automatically have filter controls added to them. So now, each column has a filter that can be applied to the data in that column. In the Order Date column, you can filter on the years. In product line, you can filter on the different product types. And in customer name, you can filter on each customer by name. Let's first filter on the year. We'll select orders from 2004 only by deselecting the other year. And if you wanted to, we could expand the year and filter by months also, but we won't do that for now. If you look at the status bar at the bottom of the worksheet, you can see that there are only 50 out of 114 records now displayed. If you want to clear a filter, you can either click the Clear Filter From option or click the Select All item in the filter list. Now, let's filter on the product line column to display only the rows that hold data for sales of classic cars. And again, we'll clear the filter. Lastly, we'll filter on the customer name column and only display sales to Mini Gifts Distributors Limited. And then clear that filter. So far, we've only applied one filter at a time, but suppose you want to filter down to a greater degree. We can do that too by just enabling all those filters together. And now we are only displaying sales of classic cars to Mini Gifts Distributors Limited in 2004. Remember, if you only want to clear one filter, then click its filter button in the column header and click the Clear Filter From option. But if you want to quickly clear all filters, you can use the Clear button in the Sort and Filter group on the Data tab. So far, we've used what are commonly referred to as auto filters, but you can also use custom filters to specify other criteria to apply to a filter to text or numbers. For example, if you wanted to see sales orders that are over or under a certain value, you can do that with custom filters. For the sales column, let's add a number filter that only displays sales that are over $2,000. If you look in the status bar, you can see that we are now showing 111 out of 114 records. Then let's clear that filter and filter it the other way to display the sales orders that are below $2,000. We can see that there are only 3 orders that are below $2,000. It's important to note that the data rows that we don't see have not been removed. They are still there. They have just been hidden from view by the filters. And this is indicated by the row numbers you see on the left in blue. The row numbers start at 69 and jump in large increments, indicating that there are many more rows of data in our data set than are currently being displayed. Let's clear those filters. If we look at a column filter for a column that contains text, you will see that the menu item changes to text filters instead of number filters. And you can see that there are several text filter options. And if you want to turn off filtering altogether for a worksheet, just click the Filter button on the Data tab. Now let's take a look at the basic sorting capabilities in Excel. Sorting is a very important part of the role of a typical data analyst. You might need to organize your text-based data alphabetically, your number-based data numerically, or your date-based data chronologically. When you sort data using these logical parameters, it makes it easier for you to conceptualize and visualize your data in a more meaningful way. When sorting data, the first thing you need to do is select which data to sort. For example, if you want to sort your customers alphabetically, select a cell in the customer name column first, and then either sort by A to Z or by Z to A. And if you want to sort your sales figures numerically, select a cell in the sales column first, and then either sort from smallest to largest or from largest to smallest. And lastly, if you want to sort your customers' order dates chronologically, select a cell in the order date column first, then sort from oldest to newest or from newest to oldest. But you can also sort your data by more than one column at a time. Simply select a cell in your data, then on the Data tab, click Sort. Then either use the Sort by Column suggested or use the drop-down list to select a different column. In this case, we'll choose the Order Date column as our first sorting criteria, and we'll choose oldest to newest in the Order drop-down list. To add a further sorting level, you click Add Level. Then you choose another sort column in the Then By drop-down list. In our case, we'll choose Sales. And for this sort level, we'll choose largest to smallest in the order list. If you have a header row in your data, as we do here, then ensure you select the My Data Has Headers checkbox, then click OK to sort. So, the data is now sorted to list the oldest orders by order date first, then within each order date, if there are multiple instances with the same order date. Then, the next sorting level lists data by the largest order values first, down to the smallest order values. In this video, we learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets. In this video, we will listen to several data professionals discuss the importance of filtering and sorting your data. Why is it important to filter and sort your data?
Filtering and sorting are very important as part of your analysis and visualization experience, because this allows you to create one single view of the data, but then provide a function for people to be able to do their own analysis on it. Now, just to clarify, what we mean by this is sorting tends to be highest to lowest, alphabetical, or in some cases, you may want to create some custom sorting where you put your particular product or offering at the start and then have the rest fall in behind it. Or you may want to group a few at the start to show your direct competitors versus others.
I love the filter and sort feature in Microsoft Excel. What it allows me to do is get to the heart of the data. I can drill down and see, for example, how much revenue a client had for a specific time frame or how much money they made in a specific time frame without looking through a lot of rows and a whole lot of information. So filtering and sorting really allows you to narrow it down and to get very specific and get the answers that you're looking for and not just get loads of data that you don't necessarily need.
Now, when we talk about filtering, we talk about this to mean that I have a particular value on which I want to see the data specified by. So for example, if we had a bar chart showing our sales over months, and I want to see it in a particular geography or for a particular product line, I could have that available and allow me to filter down so that my sales would be specific just to one geography or one product line.
Now that we've learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets, in this video we'll discuss how to use some of the most common functions a data analyst might use, namely if, ifs, countif, and SUMIF. First up, let's look at how to use the if function. The if function is one of the most used logical functions in Excel. The if function enables you to logically compare a value against criteria you set in the function, and then return a result based on whether the result of the logical comparison is true or false. And these values can be text values or numeric values. An if function essentially says, if something is true, then return a value or do something. But if it's not true, then return a different value or do something else. For example, in our vehicle toy sales worksheet, if we wanted to have a column that recorded whether the order had been shipped or not, you could add a new column to the right of the existing column, let's call it shipped, and then enter the formula seen in cell H2. This formula is saying if the text in G2 says shipped, then return yes, and if it doesn't, then return no. You can then use the fill handle to copy this formula down the column. You can see that most of the cells do say yes, but some don't, as the order hasn't been shipped for one reason or another. We could also use the if function to emphasize the size of an order. So, if we add a new column to the right of sales, and name it 3K plus or minus. Then enter the formula seen in cell F2. This formula is saying if the order is over 3,000, then return the text over 3K. But if it isn't, then return the text under 3K. And we can copy the formula down the column. In an ideal world, you would only use the if function to apply one or two conditions, but there may be scenarios where you would want to apply multiple conditions. In these cases, you can use the nesting capabilities of functions to bring together several if statements in one formula. These are called nested if functions. For example, if we add another column here for the order size, and then enter the formula seen in cell F2, you can see that this formula contains multiple if functions. One is needed for each condition, one for large, one for medium, and one for small, and it requires 3 sets of parentheses. So it's a relatively long and complex formula, but it does work. Again, we can copy the formula down the column. Even though Excel technically supports the nesting of up to 64 different if functions in a formula, it is not a recommended best practice. Having multiple if functions in a singular formula can become extremely challenging to manage. For example, suppose you come across a formula like this that you haven't used for some time, or even worse, was created by someone else. It could be quite difficult to work out how and why it is being used. Also, if your conditions increase, then you need to add more conditions to an already quite complex and long formula, which will only complicate matters more. To resolve this issue, a new function was developed called ifs. The ifs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. As the name suggests, this function can replace multiple nested if functions being used in a single formula to simplify matters. So if we add a further column for order size, but this time we'll use the ifs function instead. As you can see in cell G2, this formula only has one set of parentheses instead of 3, and only uses one function instead of 3. Let's copy that formula down the column too. Now let's have a look at another example of using the if function, but we'll combine it with conditional formatting too. If we switch to the car sales worksheet and add a new column to the right of the year resale value column and call it retention percent, then we enter the formula seen in cell G2, which will divide the year resale value by the original retail price. We need to format this as a percentage, and then we can copy it down the column. Next, we'll add a column to highlight the retention value for each car. The formula we add here in cell H2 uses the if function to state that if the percentage in the previous column is greater than 69%, then mark it as good. But if it isn't, then mark it as poor. Once again, we copy the formula down the column. We could also use conditional formatting to highlight the retention value percentages even more. We select H2 and on the Home tab, click Conditional Formatting and make a new rule. The condition in our rule will only format cells that contain a specific text value, and that value is the word good. And if it does match that condition, then format it with a dark green font and fill the cell in pale green. Let's copy that conditional formatting down the rest of the column. You can see that the cells that contain the word good are now formatted as we defined, but the cells containing the word poor are not. Let's add another conditional format rule. This time, we'll select Manage Rules because we are going to add another rule to our existing rule. The new rule will be the same as the previous one, with the exception of looking for a match with the word poor instead, and formatting those matching cells with red text and a pink background fill. And once again, we copy that down the column. Now, all the cells that contain the word poor are formatted as red text with a pink cell fill. Let's now have a quick look at how to use the COUNTIF function. COUNTIF is one of the statistical functions provided in Excel. You can use it to count the number of cells that meet a certain criterion, such as the number of instances where an employee's name appears in a list of sales invoices, or the number of occasions a particular part number appears in a list of purchase orders. Let's switch to the vehicle toy sales worksheet. Suppose you want to find out how many of the sales orders in the list went to customers based in the United Kingdom. We enter the formula you see in cell AD7. Note that when we are using text as a criterion, we have to enclose the text in quotation marks. So there were 6 sales orders in the UK. And if you wanted to discover the same thing for French customers, then you would just edit the existing formula or copy it and then edit it. You can see there were 14 orders for French customers. Notice that this time the text entered was in lowercase, and it still works, so names in this function are not case sensitive. And let's do the same for United States customers. There are 41 orders to customers based in the States. There is also a newer function called COUNTIFs, which applies criterion to cells across multiple ranges to count the number of occasions where all criteria have been met. This removes the need to use multiple COUNTIF functions in a long and complex single formula. The COUNTIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. Now let's take a look at how to use the SUMIF function, which is a very commonly used mathematical function in Excel. You use the SUMIF function to sum the values within a specified range that meet specified criteria. For example, you might want to add up only the salaries that are over a specified salary level, or you might want to find the total of all sales of a particular product category. We'll enter the formula seen in cell AD10. This formula will add up each of the sales orders that have a total of more than $3,000. Again, notice that because we have used an arithmetic operator, that is, the greater than operator, we must enclose the criterion in quotes. If we specify a criterion that is only a number, we don't enclose it in quotes. So, the total sum of all orders that were over $3,000 is almost $470,000. You can also use wildcards, such as question mark and asterisk, when searching for partial matches, and you can also specify to extract values from a different column than the column where you have specified the criteria. For example, if we enter the formula you can see in cell AD13, it will sum all the car sales in column E for only those products in the product line column that end in cars. There is also a newer function called SUMIFs that you can use to sum cells based on multiple criteria. This removes the need to use multiple SUMIF functions in a long and complex single formula. The SUMIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. In this video, we learned how to use the if, ifs, COUNTIF, and SUMIF functions. In the next video, we'll look at how to use the VLOOKUP and HLOOKUP reference functions. Now that we've learned how to use the if, ifs, COUNTIF, and SUMIF functions, in this video we'll look at how to use the VLOOKUP and HLOOKUP reference functions. VLOOKUP is one of the most commonly used reference type functions in Excel, and it enables you to find data referenced in a lookup table. It stands for vertical lookup, and therefore is a useful tool when you want to find something in a table or a range by row. Shortly, we will look at HLOOKUP, which stands for horizontal lookup, which looks for data by column instead. VLOOKUP works by using a common shared key between the source data and the lookup data in the lookup table. A typical lookup formula would look like $VLOOKUP, open parentheses, B3, comma, A2 colon B12, comma 2, comma, false, close parentheses, where B3 is the lookup value, that is, the value or word you are looking for. A2 colon B12 is the lookup table or range, that is, the table array or range of cells that contains the lookup value. In a formula, Excel references this as table underscore array. The lookup table can be on the same worksheet or in another separate worksheet. 2 is the lookup column number, that is, the number of the column in the lookup table that contains the value you are looking for. In a formula, Excel references this as col underscore index underscore num. False is an optional parameter that determines whether the match found has to be exact, denoted by false, or can be approximate, denoted by true. In a formula, Excel references this as open square bracket, range underscore lookup, close square bracket. The square brackets round this argument in the formula signifies that it is an optional argument, whereas the others are required arguments of a VLOOKUP formula. If you don't specify the optional false or true parameter in your formula, it will default to false. That is, an exact match is required. You can also use the number 0 instead of false and the number 1 instead of true. Okay, now let's see the VLOOKUP function in action. In the car sales worksheet, suppose we wanted a quick price list of our favorite cars. The first thing we need to do is put the column containing the value we want to search for in the leftmost column, as VLOOKUP requires this. Then we can delete the original column. We then enter the formula seen in cell V16, which is looking for the word Corvette in the table array from cell A2 to G156, and then looks for the value in the fifth column, in this case, the price column, that matches the row containing Corvette and returns an exact value of $45,705. Note that in this example, we are using a part of our existing data table as the lookup table or table array. Let's format that as US currency. Then we'll format it to 0 decimal places. In fact, rather than use the reference A25 in the formula, it will be easier to use the reference to the word Corvette in the mini table in this worksheet where our list of favorite cars is. So that is V5, and the formula still works. Now let's copy that formula up to the favorite car table above it in the worksheet. But there's a problem, because when we copied the formula, the cell references changed. This happened because, as we learned earlier in this course, the default state of cell references is relative, and we want them to be absolute in this case. So let's undo that copy operation. To make the cell references absolute, we need to add dollar symbols to all the cell references in the formula. This can either be done manually, or you can put the cursor in each cell reference in turn in the formula and press F4 each time to automatically add the dollar symbols. Let's try and copy the formula again, and this time it works. If we use the fill handle on cell W5 to copy it down to the rest of the cars, it doesn't work. In fact, we end up with the same result in every cell. Why? Because each one is referencing the same cells in the lookup value, because we used an absolute reference. All we need to do now is modify the formula to remove the absolute reference for just the row parameter in the lookup value part of the formula by removing the dollar symbol. So in cell W5, we change $V$5 to $V5, comma. Then, when we drag the fill handle down, it will copy the formula correctly, and all the prices will be changed to reflect their correct retail price. Lastly, to show that the two tables are now connected by this VLOOKUP function, if we change the retail price for the Chevrolet Corvette in the main data table in cell E25, the price will also change in the favorite car's price list. Let's now take a look at the HLOOKUP function, which, as we mentioned earlier, does the same thing and works in virtually the same way as the VLOOKUP function, but it looks for data in columns rather than rows. So, HLOOKUP looks for a word or value in the top row of a table, and then returns a value in the same column from a row specified in the table array. Therefore, you would use HLOOKUP if your comparison values were situated in a row along the top of a data table. In contrast, you would use VLOOKUP if your comparison values were located in a column to the left of the data you want to find, as they were in the previous task. Of the two functions, VLOOKUP is used far more frequently than HLOOKUP because of the nature of most data tables. The syntax for HLOOKUP is identical to that of VLOOKUP, except that you specify a row index number, referenced in a formula by Excel as row_index_num. This indicates the number of the row in the lookup table that contains the value you are looking for. Let's create a small lookup table on the right-hand side of our main data table. A few columns have been hidden in this worksheet to make viewing a little easier. So now we've got low HP, medium HP, and high HP in the top row of our lookup table. Next, we'll add wingding symbols as ratings for the 3 horsepower levels. 1 sad face for the low horsepower rating, 2 neutral faces for the medium rating, and 3 happy faces for the high horsepower rating. Now, let's add a new column to the right of the HP level column and call it HP rating. Then in cell L2, we'll enter the HLOOKUP function. This function will look for the value in cell K2, which in this case is medium HP, and it will look for it in the cell range from Y21 to AA22, which is our little lookup table, and it will return the answer it finds in row 2 of the table under medium HP and use an exact value. Note that we've used some absolute references in this formula too. Notice that what is returned is the text KK, so we need to format the cell using the Wingdings font. Now, when we double-click the fill handle, the whole column shows the HP rating symbols relevant to each row's HP level value. And we're done. Although VLOOKUP and HLOOKUP are regularly still used as the de facto functions for lookup references in Excel, there is a newer function called XLOOKUP. This version is only supported on Excel desktop versions from Excel for Microsoft 365 and on Excel for the web, as well as on Excel for iPad and iPhone and Excel for Android tablets and phones. XLOOKUP is an improved and combined version of VLOOKUP and HLOOKUP together. It can work in any direction, vertically or horizontally. It also uses separate lookup array and return array values, instead of a single table array and a column or row index number. In this video, we learned how to use the VLOOKUP and HLOOKUP functions in Excel to find and connect to data referenced in both vertical and horizontal lookup tables. In the videos coming up in the next lesson, we'll start to look at using pivot tables in Excel. Now that we've learned how to use the VLOOKUP and HLOOKUP functions, in this video we'll look at how to create and use pivot tables in Excel. We'll first look at how to format our data as a table, then how to create pivot tables and use fields in a pivot table to analyze data. And lastly, we'll see how to perform calculations in a pivot table. Having a worksheet full of informational data is all very well, but to really get some use out of it, we need to analyze it from different perspectives to find answers to questions related to the data. Now, we've already used features such as filters and formulas to draw mathematical and logical conclusions about our data. But not all questions can be answered easily using filters and formulas alone. In order to obtain usable and presentable insights into your data, you need something else, and that something else is pivot tables. Pivot tables provide a simple and quick way in spreadsheets to summarize and analyze data, to observe trends and patterns in your data, and to make comparisons of your data. A pivot table is dynamic, so as you change and add data to the original data set on which the pivot table is based, so the analysis and summary information changes too. A data analyst can use pivot tables to draw useful and relevant conclusions about and create insights into an organization's data in order to present those insights to interested parties within the company. Before you start to create a pivot table in Excel, it can be very helpful to first format your data as a table. The reason for this is not only to make it more organized and defined and to add table styles to your data, but primarily it makes it a lot easier when adding records to the data set. In the car sales worksheet, let's first select any cell within the data, and then on the Home tab in the Styles group, choose Format as Table. Then, choose a style from the gallery. Note that Excel automatically knows the boundaries of our data range, but we can change this if we need to. And ensure you select My Table Has Headers if indeed it does. After you click OK and the data has been formatted as a table, note the filter drop-downs at the top of each column. These are automatically added when you format as a table. If we now scroll down to the bottom of the table and start adding another row of data for another vehicle, when you click Tab or Enter, note that it is automatically formatted and included as part of our table. Okay, now let's see how to create a basic pivot table and how to use fields to arrange data in a pivot table. Just before we do that, there are a few things you should use as a checklist to ensure your data is in a fit state to make a pivot table from. And these are: format your data as a table for best results. Ensure column headings are correct, and there is only one header row, as these column headings become the field names in a pivot table. Remove any blank rows and columns, and try to eliminate blank cells also. Ensure value fields are formatted as numbers and not text. Ensure date fields are formatted as dates and not text. In the worksheet, we can just select any cell in the table. Then, on the Insert tab, we click Pivot Table. Note that in the Select a Table or Range box, the table name, Table 1, is already entered for us. If we hadn't just formatted this data as a table, we would specify the cell range here instead. Under that, we need to decide whether we want to create the pivot table on a separate new blank worksheet or on this worksheet. A new worksheet is the default and is the most commonly used option. So, a new blank worksheet opens, displaying some basic pivot table instructions in the graphic on the left of the worksheet, and a pivot table fields pane on the right. You can rename the worksheet for the pivot table if you wish. To build the pivot table report, we need to add some fields from the top of the pivot table fields pane to one or more of the sections in the bottom part of the pane. For example, if we want to find out the total sales for each model of car, let's drag the manufacturer field to the rows section of the report, and then we'll drag the model field there too. But this isn't really the way we want it to look, so we'll drag the manufacturer field to appear at the top of the rows section above the model, which makes more sense with our data. Next, we'll add the price field to the column section, but again, that really isn't the way we want to view the data, so we'll drag price to the values section instead, which makes a lot more sense and looks a lot better. Next, we'll add the unit sales field to values too. So now we can see both the individual price for each model and the number of unit sales of each model. Let's add the vehicle type field to columns, but that doesn't seem very useful, so let's remove that field, which we can do in two ways, either by using the drop-down menu, or if we undo that, we can also do it by simply dragging the field out of the columns section, either to the left over the worksheet or to the top over the fields list above. Let's now look at how to perform a simple calculation in a pivot table. If we look at the sum of price column in our pivot table, we can see that the figures are formatted as general. So first, let's change the format of these figures to US currency. This can be done by modifying the value field settings for the field in the relevant section of the pivot table fields pane. We'll format the field as US dollars and show no decimal places. Next, we'll add a calculated field from the Pivot Table Analyze tab using the Fields, Items, and Sets button. We want this field to calculate the total sales for each model by multiplying the price by the number of unit sales. When we create and add this formula, it gets added to the Pivot Table Fields pane as a field called Total Model Sales. And we can change the format to make it US dollars again. A new column called Sum of Total Model Sales has now appeared in the pivot table in our worksheet. In row 5, we can see that there have been over $360 million of sales of the Acura Integra model. And in row 7, we can see that there has been over $1 billion in sales of the Acura TL model. In this video, we learned how to format data as a table, how to create a pivot table, and use fields to analyze data in a pivot table, and how to perform calculations using pivot table data. In the next video, we'll look at some other features of pivot tables. In this video, we will listen to several data professionals discuss their experience using pivot tables to analyze data. What are your experiences using pivot tables to analyze data?
My experience using pivot tables in Excel is extensive. I can use them all the time. The thing to keep in mind is that you can sum, average, and count easily. You can set it to group by so people can choose what the parameters are at the top. It's great if you've got a couple of thousand records all the way up to whatever Excel can handle. So a pivot table is just a real simple way of manipulation without having to do any actual querying or development language.
I once had a huge e-commerce sales data. I need to analyze the KPIs, including gross merchandise volume and take rate. However, I can only generate limited insights if I stay at a high level. With pivot tables, I was able to group the data in terms of countries, type of stores, type of products, which enable me to view the data and analyze the key KPIs at different levels of granularity.
I use pivot tables, and we use pivot tables in our firm, especially during audits, to assist us and help us to kind of drill down on the data. Because what a pivot table does is it helps you to take a large set of data and whittle it down to something that's meaningful. So in the case of audits, a client might have, $500,000 worth of maintenance and repair bills that are made up of 300 invoices. Well, we don't want to see every invoice for every dollar. We want to see the high dollar invoices. So we're going to use that pivot table to narrow it down to the invoices that actually are going to have the highest level of impact on the financial statement.
Much like Excel, pivot tables are a great way to understand your data quickly and effectively. Being able to just open up an Excel sheet, put it into a pivot table, drag and drop things in to get a sense of what the numbers look like, what the values are, really can help you get a good sense of the data in order to then start to build out something a little bit more robust. Being able to understand the fields, what they mean, what they look like, these are all things that can help you at the start of a project as you're looking to do your analysis.
Pivot tables are incredibly useful to get a quick view of your data and to look at multiple levels of your data in a very quick and clean way. It's just very, very easy to create a pivot table on a set of raw data, aggregate it by some level of interest, be it country, be it country the user's from, be it the year the user joined, or anything else, be it something related to time. It's really good for quickly seeing and understanding some of the more high-level summaries that are hidden within your data.
Now that we've learned how to create and use pivot tables in Excel, in this video we'll look at some other features that we can use with pivot tables, including recommended pivot tables, filters, slicers, and timelines. First, let's look at recommended pivot tables, which isn't exactly a feature as such. It's really more of a list of suggested different combinations of data that could be used when creating a pivot table. These recommendations are based on the data we select in the worksheet, and they are a great way to get started creating pivot tables if you don't have much experience with them yet. For example, in the Vehicle Toy Sales worksheet, if we select column B, which contains data about the quantity of items ordered, when we choose recommended pivot tables from the Insert tab, then we are presented with a list of potential data combinations related to the order quantity information. However, if we select column F, which contains order size information, then the recommended pivot table list changes to reflect that data. And if we select column E, which contains sales information, then the pivot tables recommended are related to sales data. Let's select the third one down, which is the sum of sales by territory, because that sounds like something we could get some useful insight from by presenting it in a pivot table. Note that the new worksheet is opened containing the recommended pivot table, and a new pane opens on the right called Pivot Table Fields. Let's rename the worksheet to something more meaningful. In the Pivot Table Fields pane, you can see that some fields have already been added to the rows and values areas. Although it's a recommended pivot table, we can still make it our own by adding more fields, for example. So let's add the product line item to the columns area using drag and drop. Now we have columns for each of the product lines in our pivot table, such as motorcycles, ships, and trains. In the pivot table, we can manually expand any field we want to view its contents. Here we can see that the order dates are located underneath the territory names in our pivot table. Note that this matches the order of the fields in the rows area of the Pivot Table Fields pane. We can manually collapse each of the fields too, but we also have the option of expanding all the fields at once and collapsing them all too. The next feature we will delve into is pivot table filtering. Pivot table filters work in much the same way as the standard filters we used earlier in the course. Note that we already have some inbuilt filtering in this pivot table. For example, the rows label header is a filter, and we can filter on any of the listed territories, such as Japan. Just like standard filters, it's very simple to clear a filter in a pivot table. We also have a column labels filter, allowing us to filter on any of the product line items in this pivot table. For example, we could show data only for the trains product. We also have the option of adding the product line field as a standard filter instead of a column heading by dragging it to the filters area in the Pivot Table Fields pane. And we can then use it as a standard filter as we have done earlier in this course. The filter also allows us to select multiple filter items, but because it's now being used as a standard filter rather than a column header, we can't see the split of the information on these two product lines. We just see a combined total. When we had the filter as a column header, the information on each product line was presented separately in each column. Let's display all the field totals again, and we'll drag the product line field back to the columns area where it was previously, so we can see the split of our different product lines in the pivot table. The next pivot table feature we will look at are slicers. Slicers are essentially on-screen graphical filter objects that enable you to filter your data using buttons. Slicers make it easy to perform quick filtering of your pivot table data, and they also display the current filter state, making it easier for you to know and see what data is currently being shown and which is being hidden by the filter. For example, If we remove the product line field from the pivot table by dragging it out of the pivot table fields pane, and then from the pivot table Analyze tab, we click Insert Slicer and then choose the territory field as our slicer, we can see that the slicer can be freely moved around anywhere on the worksheet, and it contains buttons for each of the territory names, such as EMEA, North America, and Japan. We can also select the Multi-Select button to filter on multiple territories if we wish. We can click the Clear Filter button to clear all the slicer filters. Let's add another slicer to our worksheet for the product line field. However, be sure to select a cell in the pivot table first, because if you don't, then the Insert Slicer button won't work. Note that slicers can also be added from the Filters group on the Insert tab, as well as from the Pivot Table Analyze tab. We'll select the product line field this time for our slicer and drag it near the top of the worksheet. As before, we can select only one slicer item, or we can turn on multi-select and choose several items to filter on in the slicer. Then let's clear the slicer filters. And now let's filter using both slicers. Note that when you use multi-select filtering, when you select an item, you are in fact filtering it out. That is, you are defining which items will not be displayed in the pivot table. This is the opposite behavior to when you were selecting single items in a slicer. So now we are displaying only classic cars, trains, and trucks and buses products for the EMEA and North America territories. Now let's clear those slicer filters and put the product line field back in the columns area of the pivot table, so it's ready for the next feature we will explore. And let's move these slicers out of the way further down the worksheet. The last useful feature for pivot tables we are going to look at is timelines. A timeline is another type of filter tool that enables you to filter specifically on date-related data in your pivot table. This is a much quicker and more effective way of dynamically filtering by date rather than having to create and adjust filters on your date columns. We can add a timeline for our pivot table either from the Pivot Table Analyze tab or from the Insert tab. Again, ensure you select any cell in the pivot table first. We'll select the Order Date field as our timeline filter. Then we can drag it up the worksheet and enlarge it. The default for this timeline is to display data by month, but you can also filter by days or by quarters. You can select a single quarter or you can select a range of quarters. In this case, we'll select 12 months between quarter 3 of 2003 and quarter 2 of 2004. You can use the Clear Filter button to clear a timeline filter. You can also filter by years. For example, here we have selected 2003 only. And you can combine slicers and timelines as filters in a pivot table. For example, here we can filter the slicers to display only data for trains in the EMEA and North America territories and only in the year 2003. And if we filter on the year 2004 instead, you'll see that there is no data being displayed, meaning that there were no sales of train products in 2004 in either the EMEA or the North American territories. Timelines and slicers have their own tabs in the ribbon when you select them, and their properties can be modified to change how they look and how they work. For example, let's change this timeline to a light green shade. And let's change this slicer to a nice orange color. And lastly, to remove a timeline or slicer, you can either select it and press the Delete key, or right-click it and choose Cut. In this video, we learned about some of the other features in Excel that we can use with pivot tables, namely recommended pivot tables, filters, slicers, and timelines. It is often said that a picture is worth 1,000 words. This phrase is especially relevant when it comes to data analytics. Data visualization plays an essential role in the representation of both small and large-scale data. This course from IBM is designed to help you tell a compelling story with your data using various visualization techniques. You will work with both Excel and Cognos Analytics to acquire the basic skills needed to create different types of plots, charts, and graphs, and build interactive dashboards, which are important parts of the skill set required to become a data analyst. You will not only learn data visualization techniques using Excel and Cognos Analytics, but also practice using multiple hands-on labs and assignments throughout the course. In Module 1, you will learn about different types of charts and the Excel functions that are used to create basic charts and pivot chart visualizations. By learning how to manipulate these features and by creating visualizations, you will begin to understand the important role charts play in telling a data-driven story. In Module 2, you will learn about creating advanced charts and learn the basics of dashboarding and how to create simple dashboards in Excel. You will also learn how dashboards can be used to provide real-time snapshots of key performance indicators. In Module 3, you will learn about Cognos Analytics, including how to sign up for it, how to navigate around it, and how to easily create stunning dashboards. You will also learn some of the more advanced dashboarding capabilities of Cognos Analytics and make your dashboards interactive. In the final module, you will complete a 2-part hands-on final assignment lab, which will guide you on how to create visualizations in Excel and how to create visualizations and dashboards in Cognos Analytics. This will involve you understanding what the scenario requirements are and then creating visualizations and a dashboard to fulfill those requirements. You will follow 2 different business scenarios throughout the course, with each using their own data set. These different scenarios and datasets will be used in the lesson videos and in the hands-on labs. After completing this course, you will be able to explain the role visualizations play in conveying a story about data, create basic charts, pivot charts, and advanced charts in Excel spreadsheets, create a simple dashboard using Excel, provision an instance of Cognos Analytics in the cloud, navigate around the Cognos Analytics interface and leverage its rich visualization capabilities. Build interactive dashboards using Cognos Analytics with a variety of basic and advanced visualizations. You will also perform some intermediate-level data visualization and dashboard creation tasks to address a business scenario. The course team and other peers are available to help in the course discussion forums in case you require any assistance. Let's get started with your next video where you will get an introduction to charts. In this video, we'll give an overview of several different types of charts and visualizations and discuss how they can be used to tell a story. Let's begin by looking at a line chart. When comparing different but related data sets, a line chart is a great way to display the information. They are able to display trends and show how a data value is changing in relation to a continuous variable. For example, if time is a continuous variable, how has the sale of a product or multiple products changed? Next, we have pie charts. This type of chart can show the breakdown of an entity into its subparts and the proportion of the subparts in relation to one another. Each portion of the pie represents a static value or category, and the sum of all categories is equal to 100%. In this example, we have a marketing campaign with 4 distinct categories: social sites, native advertising, paid influencers, and live events. With this type of data representation, we can easily see the total number of leads generated per category. We now look at one of the most commonly used charts, the bar chart. This type of chart is the most common as they are easy to create and are great for comparing related datasets or parts of a whole. For example, in this bar chart, we can see the population numbers of 10 different countries and how they compare to one another. We can also use stacked bars, in which each bar is divided into sub-bars that are stacked end to end. In this stacked bar, we can see the population of each country split into 4 age ranges. Would you like the graph to appear vertical and not horizontal? Then column charts would be a great pick. This type of chart can be used quite effectively to show change over time and to compare values side by side. For example, showing page views versus user session time on a website as it changes on a month-to-month basis. While this type of chart looks similar to a bar chart, they cannot always be used interchangeably. For example, a column chart may be better suited for showing negative and positive values. Next, we have tree maps, which are useful for displaying complex hierarchies using nested rectangles. In this example, the tree map depicts statewide employment rates within the population of a country over the last year. The size of the rectangle represents the population, and the color represents the employment rate. We can click on any region to see the employment data of the subregions within the selected region. Trying to display a pipeline or different stages of a continuous process? Then funnel charts are the way to go. In this example, the funnel chart is showing the conversion rate at each stage of the sales process, from lead generation to the final sale. Another exceptional chart is the scatter chart. In this type of chart, the circle colors represent the categories of data, and the circle sizes are indicative of the volume of data. For example, in this scatter chart, we can see each product line by the number of units sold and the revenue it brings. A scatter chart can be great for revealing trends, clusters, patterns, and correlations between data points. Next, we look at bubble charts. This is a variant of scatter charts, and they are useful for comparing a handful of categories to one another in terms of relative significance. For example, understanding areas of significant expenditure in an organization's sales budgets. Lastly, we have spark lines. Spark lines do not include an axis or coordinates, yet they display trends simply and effectively. These are great for showing the general trend of a variation. For example, stock market price fluctuations from the opening to the closing of a trading day. In this video, we learned about the importance of charts and how they are able to shape our data to provide meaningful information. In the next video, we will dive into more details about how to create and configure different types of charts in Excel. In this video, we will listen to several data professionals discuss the importance of using visualizations to tell a story about data. Can you tell us about the importance of using visualizations to tell a story about data?
Visualizations are critical to storytelling with data. I think you're familiar with the phrase, a picture is worth 1,000 words. And that's really true here. You can get a much clearer picture of what's going on with your data if you have clean and clear data visualizations. I also think data visualization is super helpful for the analyst that creates them because it forces them to make choices about what's really important to show and what isn't important to show. For example, if you're debating whether you should look at things temporally, you can debate like, is the overall trend the most important? Okay, then I should do a time series data visualization. Do I think comparing one group versus another is more important? Then you're more likely to do a bar or column chart. So it's really important in clarifying the data analyst's thinking, and visualization is really important in telling a clear, concise story to stakeholders.
Humans are visual creatures. You are more likely to tell a compelling story and get buy-in with visuals. I once got a job offer with a visualized resume created by Tableau.
So one of the best ways to present data is visually. Numbers by themselves for the most part, will tend to overwhelm people. So if I walk up and I'm talking in a company meeting and I say, well, last year in 2019, we did $100,000. Or I could give you a graph and say 2018, we did 75,000. 2019, we did 100,000. In 2020, we're projected to do $125,000. And if I put that in a graph and make it stand out and make it pretty, non-accountants will, and non-data people will kind of gravitate towards it, and it'll prompt them to ask different questions and have different ideas. And so by using maybe a PowerPoint or even Excel, in Excel you can create graphs from the data, make it pretty, make sure that it not just pretty, but make sure that it highlights the important information of what you're trying to say. It will create and drive the conversation around what needs to be done and how best to maybe run the business or make different decisions. Data visualization is a very important part of helping people to understand the numbers that you're trying to present.
The reason we want to gravitate towards visualizations is that's how the brain really works. The brain is much more able to process a high bar versus a low bar as opposed to looking at 100 rows or 100 lines in a spreadsheet. Using the visualizations, and especially using the appropriate visualization for the given task, can really help make sure that the user gets the easiest way to understand this. As we talked about, storytelling is really an important way for us to do this. And so through the visualizations, that's really how we tell a story. We can augment it with text, whether that's user generated or system generated, to help people really drill down further to the understanding. But starting with the visualization is the easiest way to help people quickly, effectively understand what's going on. And then you can have the further discussions around what exactly you're doing.
In this video, we'll look at how to create a few basic types of charts in Excel. We'll first create line charts, then pie charts, and lastly, bar charts. First, let's start with line charts. A line chart is a type of graph used to show information as a series of data points connected by straight lines. In a line chart, the horizontal axis typically represents time or a similar category, and the vertical axis typically represents numerical values. Because line charts can display continuous data over a given time period, they're perfect for showing trends in data at equal time intervals, such as days, months, quarters, or years. Line charts are ideal for scenarios where you have data that's arranged in columns or rows, or where your data contains multiple data series. On the car sales worksheet of the car sales workbook, let's first filter the data to display only Ford car models. Now let's create a line chart with this data. We'll select the data from two non-adjacent columns, in this case, model and price. Then we select line chart from the 2D line category of the charts group. Let's change the chart title to Price of Ford Cars, which we can do by simply double-clicking the chart title text box and editing the text. We now see a floating chart area containing our line chart, which displays the price trend of Ford cars across its models. Let's move this line chart to the left side of the worksheet below our data. Okay, now let's move on to pie charts. A pie chart is a type of circular graph used to show the relative contribution of different categories, which we see as slices, to make an overall total, which we see as a pie. Data points on a pie chart, that is, the slices, are represented as percentages of the complete pie. Pie charts provide a very simple visualization of differing data results, which we humans find very easy to comprehend. Pie charts are best used when you only have one data series, and when your data contains no more than maybe a dozen categories. Otherwise, the pie chart can start to look too busy and become difficult to read. For the pie chart, we'll use the model names manufactured by Ford along with their unit sales. To create our pie chart, we'll select the data from two non-adjacent columns, in this case, model and unit sales. Then we select Pie Chart from the 2D Pie category of the Charts group. The new floating chart area contains our pie chart, which displays the relative contribution of unit sales from individual Ford car models, which are the slices of the pie, and they combine together to make an overall total of unit sales of Ford cars, which is the whole pie. Let's change the chart style to customize the look of the pie chart. There are numerous styles to choose from in the gallery, and you can even make combinations of multiple styles. For example, here we've chosen Style 3 and Style 7, which gives us the percentage values displayed in each slice and a nice dark contrasting background color. Let's again move that chart, this time to the center of the worksheet below our data. Lastly, let's have a look at bar charts. A bar chart is a type of graph used to compare values across categories, either using vertical bars or horizontal bars in the case of column charts, which are a variety of bar charts. In a bar chart, the categories are usually arranged on the vertical axis, and the values are on the horizontal axis. Whereas in a column chart, the categories are typically arranged on the horizontal axis and the values are displayed on the vertical axis. To create our bar chart, we'll select the data from two non-adjacent columns again, in this case, model and retention percentage. Then we select a style of bar chart from the 2D bar category of bar charts. The new floating chart area contains our bar chart, which displays comparative values for the retention percentage of the different Ford models using horizontal bars. Again, we can change the chart color to customize the look of the bar chart. If you just want to choose a color scheme based on the palette of colors rather than a style, you can click the Change Colors button and then select a color palette from the list. Let's also move this chart, this time to the right side of the worksheet below our data. In this video, we learned how to create line, pie, and bar charts in Excel. In the next video, we'll look at how to use the pivot chart feature in Excel. Now that we've learned how to create a few basic types of charts in Excel, in this video we'll look at how to create some other basic charts using the pivot chart feature from a pivot table in Excel. We'll first create area charts and then column charts from a pivot table. Please note that the price and resale values in this sample dataset are not real data and are merely used for explanatory and demonstration purposes. A pivot chart is used to show the data series, categories, and chart axes the same way a basic chart is used, but connecting a pivot table with it. Simply put, a pivot chart is nothing more than a graphical representation of a pivot table in Excel. It's useful when we have a pivot table containing complicated data. A pivot chart can help us make sense of such data. Let's start with area charts. An area chart is a type of graph used to show information as a series of data points connected using straight lines with a filled area below it. Area charts can handle both positive and negative values, like line charts. First, let's create a copy of the Pivot 1 worksheet of the Car Sales Workbook. In this copied worksheet of the Car Sales Workbook, let's first filter the data of the pivot table to display only Toyota car models. If we expand the field Toyota, we can see the details of different models from Toyota, such as the average price of each model and the average year resale value. Now let's create an area chart using the pivot chart feature with this data. Here, let's select the area chart type and choose the 3D area chart. Here, we see a floating chart containing our area chart, which displays the trend of average price as well as average year resale value of Toyota cars across its models. Note that we can also filter the data in the pivot chart itself rather than in the pivot table. This is one of the key differences between a standard chart and a pivot chart. So, in our pivot chart, let's filter the data to display only Chevrolet car models. When we expand the field, the pivot chart displays our data. Here, we can see that it seems that the higher-priced models don't retain their value after 1 year compared to the lower-priced models. We can also use the Model Filter drop-down in our pivot chart to filter on models too. Now we are only displaying 7 of the 9 Chevrolet models in our pivot chart and its associated pivot table. So we can see that when we make a change, such as adding a filter, directly in our pivot chart, those changes are immediately reflected in our pivot table data. And the reverse is obviously also true. If we make a change in our pivot table, that change is immediately viewable in our pivot chart. Now let's have a look at column charts. A column chart is a type of graph used to compare values across categories using vertical bars. In a column chart, the categories are typically arranged on the horizontal axis, and the values are displayed on the vertical axis. To create our column chart, let's first create another copy of the Pivot 1 worksheet of the Car Sales Workbook. In this copied worksheet of the Car Sales Workbook, let's again filter the data of the pivot table, but this time to display only BMW, Cadillac, and Hyundai car models. Now let's create a column chart using the pivot chart feature with this data. Here, let's select the column chart type and choose the 3D clustered column chart. The new floating area contains our column chart, which displays comparative values for the average price as well as the average year resale value for BMW, Cadillac, and Hyundai cars using vertical bars. From this chart data, we can see that it seems that both the Hyundai and BMW ranges retain their 1-year resale value better than the Cadillac models do. Now let's view all the BMW models in the table and chart by expanding the cell in the pivot table. But note that we can also use the plus and minus buttons in the chart to expand and collapse the data view too. These buttons can drill down and drill up through multiple category levels if you have multiple fields in the axis or categories section of the pivot chart fields pane. For example, if we had the models further categorized into model variants and then into engine capacities and then into colors and so on. Now we can see all the models for all 3 manufacturers displayed in our column chart. Note, however, that these buttons can only be used to expand or collapse all fields. If you want to expand or collapse just one field, then you need to do it in the pivot table rather than the chart, as we did in the previous step. Let's change the chart style to customize the look of the column chart. There are numerous styles to choose from in the gallery. For example, here we've chosen Style 9, which gives us a nice dark contrasting background color. In this video, we learned how to create area and column charts using the pivot chart feature from a pivot table in Excel. We also learned how to filter data using either the pivot table or the pivot chart, and we learned how to expand and collapse data levels using both the pivot table and the pivot chart. In the next video, we'll look at some advanced charts available in Excel. Now that we've learned how to create basic charts, in this video we'll look at how to create some advanced charts in Excel. We'll first create tree maps, then scatter charts, and lastly, histograms. Please note that the price and resale values in this sample dataset are not real and are merely used for explanatory and demonstration purposes. Let's start with tree maps. A tree map chart is used to compare values across hierarchy levels and show proportions within hierarchical levels as rectangles. Tree maps are a good way of displaying lots of data in one graphical asset because they use the color and closeness of proportional shapes within the chart to represent hierarchical data categories, which is a difficult thing to achieve with most other types of chart. In the tree map worksheet of the Car Sales Workbook, let's first select the data from 2 non-adjacent columns, model and unit sales. Now let's create a tree map chart with this data. We select Tree Map Chart from the hierarchy category of the charts group. We now see a floating chart area containing our tree map chart, which displays the proportion of the unit sales of Ford cars within hierarchical levels as rectangles. Let's change the chart title to Unit Sales of Ford Cars, which we can do by simply double-clicking the chart title text box and editing the text. Let's change the chart style to customize the look of the tree map chart. There are numerous styles to choose from in the gallery. For example, here we've chosen Style 2. We can easily see from this tree map chart that the F-Series model is by far the biggest proportion of our Ford car sales, followed by the Explorer and Taurus models, which constitute a similar proportion of our Ford car sales, while the Contour model shows the smallest proportion of Ford car sales. Next, let's have a look at scatter charts. A scatter chart is a type of graph used to compare two sets of numerical data values and show relationships between those sets of numerical values. A scatter chart combines the two sets of values on the x and y axis into single points of data, and then displays them in clusters in the chart. For this reason, you will also sometimes see them referred to as XY charts. Common uses include the comparison of statistical, scientific, or engineering data values. To create our scatter chart, let's first select the data from two adjacent columns, price and year resale value, in the scatter worksheet of the car sales workbook. Now let's create a scatter chart with this data. We select scatter chart from the XY scatter category of the charts group, which compares the price of cars from all manufacturers with their year resale value. Let's change the chart title to Comparing Price with Year Resale Value, which we can do by simply double-clicking the chart title text box and editing the text. Let's change the chart style to customize the look of the scatter chart. There are numerous styles to choose from in the gallery. For example, here we've chosen Style 8. Now let's add some axis titles for both the horizontal x-axis and the vertical y-axis. We'll call the horizontal Retail Price and the vertical Year Resale Value. We can see from this scatter chart that as the retail price increases, so does the differential between the retail price and the year resale value. Generally speaking, the lower-priced cars retain their resale value after 1 year better than the higher-priced cars. Lastly, let's have a look at histograms. A histogram is a graph that shows the distribution of the data grouped into bins. Although a histogram may look like a column or bar chart, it's totally different. While a bar chart is used to compare data, a histogram is used to display distribution of data. To create our histogram, let's first select the data from two non-adjacent columns, model and price, in the histogram worksheet of the car sales workbook. Now let's create a histogram with this data. We select histogram from the statistical category of the charts group. The new floating chart area contains our histogram, which displays frequency distribution of the price of cars from all manufacturers. Note how Excel automatically puts the different price ranges into 9 equally sized separate bins for you. The first bin contains cars priced between $9,235 and $18,635. The second bin contains cars priced between $18,635 and $28,035, and so on, up to a maximum price range of $84,435 to $93,835. Let's change the chart title to Count of Car Models by Price Range, which we can do by simply double-clicking the chart title text box and editing the text. Let's change the chart style to customize the look of the histogram. There are numerous styles again to choose from in the gallery. For example, here we've chosen Style 3. This style shows the count values of the individual rectangles for each price range rather than using a vertical scale on the y-axis. So, from this histogram chart, we can easily see that the largest proportion of car models are in the $18,635 to $28,035 price range. With a count of 62 models in this range, followed by the cheapest price range of $9,235 to $18,635, which has a count of 42 models, and the fewest count of models in a price range is shared by the two most expensive price ranges with only one model in each bin. Although Excel chooses your bin ranges automatically when you create a histogram, you can change the bin sizes to suit your needs. This is done by opening the formatting pane for the relevant chart element, in this case, the horizontal axis. In the Axis Options section, you can choose to display bins by several factors, including bin width and by number of bins. For example, when we change the bin width value, you can now see 15 bins in the chart because the price ranges are much narrower. Bins 2 and 3 have the two highest counts of 34 and 33 respectively, and bin 14 shows no models in this price range at all. And if we change the axis options to display a set number of bins, then the histogram updates again to show the price ranges split into the number of bins specified. That is 10 bins, and once again we can see that bin 2 has the largest proportion of models in its price range. And if we choose automatic, then the histogram reverts back to the format we started with. In this video, we learned how to create tree maps, scatter charts, and histograms in Excel. In the next video, we'll look at some of the other advanced charts available in Excel, like filled map charts and sparklines. In this video, we'll look at some more advanced charts in Excel. We'll first create a filled map chart, and then add sparklines to our data. And lastly, we'll briefly discuss some of the other charts available in Excel. Let's start with filled map charts. A filled map chart is a type of chart used to compare values and show categories across geographical regions. This chart is suitable for data which contains geographical regions like countries, states, or postal codes. In the map chart worksheet of the Car Sales Workbook, let's first copy data from the pivot table containing country of sale and sum of unit sales. Then we'll paste the copied data beside the table. Now let's create a filled map chart with this data. After selecting the data, we select Filled Map Chart from the Map category of the Charts group. The new floating chart area contains our filled map chart, which displays the sum of unit sales of cars across different countries of sale. Let's change the chart title to Sum of Unit Sales of Cars by Country, which we can do by simply double-clicking the chart title text box and editing the text. Let's change the chart style to customize the look of the filled map chart. There are numerous styles to choose from in the gallery to suit your preference. We can see from this filled map visualization that the darker blue color, which denotes the larger number of unit sales, is covering the United States, while the paler blue colors, which denote medium numbers of unit sales, are covering areas such as Canada, Western Europe, and Scandinavia. And the almost white color, which denotes the lowest number of unit sales, is predominantly covering Eastern Europe, India, Japan, and Australia. Next, let's have a look at sparklines. Sparklines are mini charts placed inside single cells to represent a selected range of data. They are typically used to show data trends, such as seasonal increase or decrease, economic cycles, and share, rate, or price fluctuations. They can also be used to highlight max and min values. A sparkline provides the greatest impact when it is placed close to the data it represents. To create our sparklines, let's first select data from the 4 adjacent columns: Unit Sales Q1, Unit Sales Q2, Unit Sales Q3, and Unit Sales Q4 in the Sparklines worksheet of the Car Sales Workbook. Now let's create sparklines with this data. We'll select the line type of sparkline from the Sparklines group. We then need to specify where we would like our sparkline to appear on the worksheet. We can do this by either typing in the cell reference in the location range box, or better still, Just click the cell in the worksheet where you want it to appear, and Excel will fill it in for you. Note that it uses an absolute reference by adding dollar symbols to the cell references. And then we can copy that sparkline down the rest of the column. We now see a column containing our sparklines, which displays the trend of the unit sales of Ford cars over the 4 quarters of a year. Let's name the column header of the column with the sparklines as Quarter Sales Trends. We'll adjust the column width and also adjust the row height to display sparklines more clearly. Let's also display maximum and minimum values on the sparklines. Then change the chart style to customize the look of the sparklines. There are several styles in the gallery for you to choose from. And finally, let's adjust the weight of the lines in the sparklines to make them stand out a bit. These sparklines show us that Ford Escort unit sales started low in the first quarter, and then increased in quarter 2 and 3, then declined again in quarter 4. We can also determine that generally across the majority of the range of Ford car models, Q3 is the best quarter of unit sales over the year, with a couple of exceptions such as Mustangs in quarter 4 and Focus models in quarter 2. Lastly, let's have a look at some other available charts in Excel. The waterfall chart type is used to show cumulative effect of a series of positive and negative values. This is suitable for data which represents inflows and outflows like financial data. The funnel chart type is used to show progressively smaller stages in a process. This is suitable for data which shows progressively decreasing proportions. The stock chart type is used to show the trend of stock's performance over time. This is best suited to data with a series of multiple stock price values like volume, open, high, low, and close. The surface chart type is used to show trends in values across 2 dimensions in 3D surface areas or 2D contoured charts. This is most suitable when categories and data series are both numeric. And lastly, the radar chart type is used to show values relative to a center point and is most suitable when categories are not directly comparable. In this video, we looked at how to create filled map charts and sparklines in Excel, and we reviewed some of the other charts available. In this video, we will have a brief introduction to dashboards, including what they are, what they consist of, why they can be a useful component in a data analyst's toolkit, and an essential skill in a data analyst's skill set. The term dashboard comes from the automotive industry, where car designers have put the most important gauges and other display information, such as engine oil temperature, current speed, current RPM, amount of fuel left, and so on, in a handy graphical display that is easy for the driver to view and understand. Originally, these displays were analog, but most are now digital and use varying forms of visualization, including digital meters and mini graphs. You can take that same idea and apply it to a dashboard in a data analysis application. Designers of these types of dashboard want to put key business information in one place, in the form of graphical displays, to make it easier for the viewer to understand them. Dashboards can take this a step further by also allowing the user to interact with the dashboard and modify exactly what information they see by using tools supplied on the dashboard. Users of a dashboard therefore not only get a consolidated visualization of their business data and key performance indicators, or KPIs, but also get a controllable self-service business intelligence, or BI interface, through the use of filters, which enable them to control precisely what information they see. Dashboards are typically created in a data analysis application by using multiple pivot tables and charts, visualizations such as map charts and sparklines, and filtering tools such as slicers and timelines. These pivot tables and charts could be created from a single data source or from multiple data sources. When you use dashboards in your data analysis application, you get the following benefits. They offer insights into your key data. They can alert you to patterns and trends in your data. They provide an interactive experience for the user, allowing them to filter what data they see. They are updated dynamically as the source data changes. They provide a centralized and consolidated view of business data. A dashboard can be a very useful tool in areas of the business such as fiscal forecasting and reporting, project management, executive reporting, human resources, customer service, help desk issue tracking, healthcare monitoring, call center analytics, social media marketing, and many more. For a budding data analyst, dashboards can be a vital skill to add to their arsenal, as the majority of employers see the dashboarding skill as a must-have rather than a nice-to-have. If you can show that you have the skills to create accomplished and spectacular, interactive, yet easy to view and use dashboards, whether in a spreadsheet application such as Microsoft Excel or Google Sheets, or using a more advanced data analysis and visualization application such as Bokeh or Dash in Python, RStudio Shiny, Tableau, or IBM Cognos Analytics, then that will greatly help you in your future career as a data analyst. In this video, we had a brief introduction to dashboards, including what they are, what they consist of, why they can be a useful component in a data analyst's toolkit, and an essential skill in a data analyst's skill set. In the next videos, we will learn how to create a simple dashboard using a spreadsheet application. In the first part of this video, we will listen to several data professionals discuss how dashboards can help when presenting data results. Can you tell us how dashboards can help you when presenting data results?
One thing I particularly love with data are dashboards. They take the fluff out and they show you the most important things that you want to see, often in real time, and you can make them as pretty as you want. I've seen some dashboards that are frankly an eyesore because of trying to cram so much data into one dashboard. So it's important to be specific and be succinct in what it is that you're looking for so that you can avoid those sorts of things. A lot of times the dashboards are great for executives or business owners on the go who are maybe looking at dashboards from a mobile device, and they don't really have the space or the capacity on a mobile device to look at so much data. And dashboards can really be highly effective in a short amount of time as long as you understand the deliverables and what it is that your stakeholder wants to see and what's important to them for purposes of making decisions.
The reason why presenting the information in a way that is palatable to your audience is important is because you want to make sure that people are getting value out of what you're doing. A lot of times I think that's why data analysts in general get a bad rep, because people think we're just number crunchers. I think the bigger problem is we haven't done as good of a job as we could to really explain the numbers. And so that's where PowerPoint presentations with graphs, we love graphs, key performance indicators, maybe that break out the information in a different way and highlight what's most important, that will help. And also just making sure that you're reading the room. So if you are in a meeting and everybody's eyes are glazed over because you're talking numbers, maybe you need to ask them, what information are you looking for? What is most important to you, so that when you go back and you create your next dashboard or create your next report, you can highlight things that are important to your audience, because we always need to be reading the room. We need to make sure that we are showing our value, showing people, helping people to understand, educating them so that they can bring up their knowledge base. And so that starts to help the fear dissipate. The fear of the number starts to go away if we would just show them what the numbers actually mean. And we can do that not just by throwing numbers at them so they'll get overwhelmed, but by helping them to see it graphically and with dashboards and KPIs and other ways just to bring it to them and make it real to them.
Dashboards in a spreadsheet is an indicator for action. Just like on your car dashboard, if you see a low fuel light, that means you need to put gas in your car. So a dashboard in a spreadsheet should be just that simple. It should tell the person what they need to focus on immediately, or any indication that things need to change because it's either going up in the wrong direction or it's going down. But don't put information that's nice to know on a dashboard. It's on a need to know basis, especially if you want to get action.
In the second part of this video, we will listen to a data professional discuss how Cognos Analytics can help you create outstanding visualization dashboards for presenting data results. Can you tell us how you use Cognos Analytics to create visualization dashboards for presenting data results?
IBM Cognos Analytics can really help you create a better visualization and dashboards in a number of different ways. Starting off, we have our templates, allowing you to quickly select from a template and simply drag and drop your visualizations into the slots to help you create something that's visually compelling effectively and easily. We also have what we call our visualization recommender. If you grab a couple fields, drag them onto the canvas, we'll recommend a visualization. If you don't like the one we recommend right off the bat, then you do have the ability to go in and start to select some different visualizations from our recommendations. On top of this, we also have started to infuse AI into the offering. So from this, you can start to have the system actually generate an entire dashboard for you. You can have a conversation with our assistant, ask it questions, and once you focus in on the particular area that you're interested in, simply say, generate dashboard. And at that point, you'll get a beautiful dashboard created, laid out nicely that you can start to use as your starting point for further discussions and help you really understand the data that's in your system. A couple of the things that we wanted to highlight. One is the advanced analytic capabilities, whether this is through our visualizations like our key driver analysis or through our AI-infused forecasting. The last thing would be the ability to share your visualizations and your dashboards in just a few clicks, whether that's sharing it in the system through a link, whether it's pushing it to email, or even pushing it into a Slack channel where you can start to have a discussion there.
Now that we've learned about the basics of dashboards and why they are an essential tool for a data analyst, in this video we'll look at how to set up and configure a relatively simple dashboard in Excel, which will help us to tell a story about our data. Before creating our first dashboard, we would have first collected and organized the data, then verified that the data in our worksheet was clean, error-free, and did not contain any blank rows or columns. And then we would have formatted it as a table. Next, we would have created some pivot tables to help us analyze our data, and we would have performed some sorting and filtering on the data in our pivot tables to highlight the key aspects of our data analysis. Lastly, we would have created various data visualizations such as charts, maps, and slicers to help us tell a story about our data findings. In this example car sales workbook, we've already gone through those processes of collecting, cleaning, analyzing, and visualizing our data. And we are now at the point where we can combine that data analysis and those visualizations in a digital dashboard that will help us present our key data findings to stakeholders. The first thing we need to do is create a new worksheet to host our dashboard and give it a name. Then drag it to the end of the tabs list in the workbook. As we've already created several visualizations, we can use those to populate our dashboard. So, if we look at some of the other worksheet tabs, these contain various visualizations which we've been working on throughout this course. We can just use some of them by copying a few charts and other visualizations from there to our dashboard. We'll copy this pie chart from this worksheet and paste it to our dashboard. Then we'll grab a copy of this 3D column chart and paste that too. We'll also copy the 3D area chart from the other pivot chart sheet to our dashboard. We'll grab the tree map chart and copy that to our dashboard too. Let's copy the scatter plot chart too. We'll also copy the histogram and copy that to our dashboard worksheet. And let's take a copy of the map chart visualization too. Let's also copy the sparklines visualization to our new dashboard worksheet. Lastly, let's go back to the line pie bar worksheet and select both the line chart and the bar charts and copy them both to the dashboard worksheet. Okay, so now we have a lot of different visualizations on our dashboard. We can make things look a little better by resizing some of the visualization objects and moving them around a bit. So we've now resized some of the visualizations and moved things around. And then we could zoom out to see all the visualizations on screen. But if we remember what we heard from some of the subject matter experts during the Expert Viewpoints video, sometimes less is more. And one or two of the experts mentioned that if we provide and display too much information, the key points can sometimes get lost. So we should create a copy of this dashboard on another worksheet, and then thin down the amount of visualizations, and maybe make them more focused to highlight one or two of the more important views we want to convey. To do that, we'll first make a copy of the dashboard worksheet and move it to the end of the worksheet's tabs. On the Copy Dashboard 2 worksheet, we'll now delete a few superfluous charts. Let's first remove the tree map because that is giving us almost the same information as the pie chart. Then we can remove the 3D column chart because that has essentially the same data as the 3D area chart. And let's also lose the scatter plot, histogram, and the sparklines because they aren't really key to our message. Let's copy the slicer from the line pie bar worksheet to our dashboard to give us some interactivity. Now let's zoom back out and do some arranging and resizing to these visualizations to make the dashboard look a little sharper. So now we've rearranged and resized the visualizations to make the dashboard look a little leaner and tidier. We should also make some style and color changes to give our dashboard a more consistent look and feel. We'll apply the same style to all the chart elements. So we'll apply a dark gray style and monochromatic green colors to the 3D area chart, and the line chart, and the pie chart, and the bar chart, and the map chart, and we can recolor the slicer too to fit in with our color scheme. Now things look a lot better and more professional, and the last thing we should do is remove some of the Excel interface elements and other bits of unnecessary screen clutter to give us a nice clean looking dashboard. We can remove screen clutter such as grid lines, the formula bar, and headings. And we can collapse the ribbon too, and that should do it. Now, when we either present this dashboard or email it to a key stakeholder, it includes some interactivity via the slicer and also via the filterable pivot chart. If we use the slicer to select several Ford car models, all three charts that are related to that data get updated at the same time. We can modify filters in the 3D area chart to display only Ford cars instead of Chevrolets. And if we switch to the Pivot Chart 1 worksheet, we can see that the original data has also been updated with this new filter. And when we make changes to the original source data, such as increasing the value of unit sales of cars in Australia, the map chart visualization in this worksheet updates and the Australia turns dark blue. But also the map chart visualization in the dashboard gets updated too. So we can see that Australia is now dark green on this map chart. All of this shows how live and interactive the data in our dashboard is. Creating a clean, focused, and interactive dashboard can be a major asset when trying to tell a story about data. In this video, we learned how to set up and configure a relatively simple dashboard in Excel, which will help us to tell a story about our data. In the next video, we will get an introduction to IBM Cognos Analytics Data Analysis and Visualization Business Intelligence Platform.
In this video, we're going to cover a couple of things. The first is a quick overview of what Cognos Analytics is, and we're going to show you how to sign up for the trial. Cognos Analytics is a multifaceted tool, allowing you to perform both Mode 1 and Mode 2 type of analysis all in one product. It contains a number of different tools, such as the ability to model your data, explore your data, create compelling advanced analytic visualizations like our key driver analysis, display natural language generated based off of your data, and create reports which are specific and tailored to your individual users, either through filters or through the ability to create bursts. We also have the ability to create fantastic dashboards, which will be the main focus of this particular course. Now to sign up for the trial, we're going to go to the ibm.biz/try_cognos. If you already have an account, you can log in here and you'll simply have to fill out part of this form. If you don't, then we'll go ahead, fill out this form quickly, and the key one to take note of is to select a data center which is close to you in your particular geography. Now the system's being spun up for us and we can go ahead and actually launch this directly from this workflow. Now that you're in, you can go ahead and either manage your subscription through this button, or alternatively, you can always re-access the system through this URL. In the next video, we'll take you through a little bit around how to navigate and use Cognos and its dashboard capabilities. In this particular video, we'll cover off how we can upload spreadsheets, general navigation in Cognos Analytics, how to start a new dashboard, using dashboard templates, as well as navigating within the Cognos Analytics dashboard environment. There are two main navigation areas for Cognos Analytics, along the left-hand side as well as along the top. These will change and update based on the area you're in the product. Now for today, while Cognos can connect to a number of databases, we're going to start with simply uploading an Excel file. Now we can do this in one of two ways. We can come to the new, select upload files, and navigate to find the file in question. Alternatively, what we can do is we can drag and drop the file onto our main landing page here and have it take us directly into the experience that we're looking to do. In our case here, dashboard. Now you'll notice that this says that uploaded content will land in my content, which is up there on the left-hand navigation. Whether you do it from here or through the plus and upload, it'll still land in the same place. Once in my content, it can be taken, moved around into a shared area within team content. As the file uploads here, you'll notice that we see something that says analyzing. This allows us to interrogate the data, get an understanding of what's in the data, in order to be able to help make some better assumptions and decisions for you as we look to build out content. The first thing we'll do as we go to build a dashboard is to select a template. You'll see a number here, and based on what you're trying to achieve, how many visualizations and what types, you may want to select something specific. In this case, I'll choose one that has 4 and 1 larger space. Once we're in the dashboard, we'll notice that the pane with our uploaded file column headers is displayed. There's a few other things that we want to highlight here in terms of navigation to help you with the experience here in Cognos Analytics. Our second pin down here allows you to pin different visualizations for reuse in other dashboards across the system. We'll come back to our assistant in a future video. This allows you to ask questions in natural language and have the system tell you a little bit about your data as well as provide some visualizations. The next system here is our view of all the different visualizations we support in the dashboard, as well as the ability to upload your own custom visualization should we not have one that meets your needs. The final one here is our additional widgets, whether that's text, images, video, hyperlinks, or any of these shapes that are viewed here. In the next video, we'll dive a little bit deeper into how specifically to create dashboards. In this video, we'll cover off creating some simple dashboards in Cognos Analytics. We'll cover off a variety of different methods for creating a visualization, whether it's through our automatic generation, manually populating slots, or using our assistant. We'll also cover off how you can filter within a Cognos Analytics dashboard. As I mentioned, as the data was uploaded, we took a look at the data and tried to understand what types of data were included. And that's denoted by the icon in front of each of these elements. Now, in the case of order ID, we actually want to switch this up and change the properties from a measure to an identifier. With that done, let's go ahead and start to create some visualizations. So I can simply grab from my tree and drag it onto the canvas. Now in this case, if I drop on top of the box, what it'll do is it'll fill the space available as denoted by the template. Next, let's look at the number of orders that we've had by counting the number of order IDs that we have. Now in this case, it determined the best visualization for an identifier to be a list. We can go ahead and take a look at what other recommended visualizations, in this case there aren't any, but we know we want to turn this into a summary, so we can just go and manually select it. Next up, let's look at the quantity ordered, and we'll finally finish with the average sale. So in this case, I'll drag sales onto the canvas, but what I'll do is I'll change our summarization from sum to average. And so just like that, I now have a few KPIs to be able to monitor and track. The other way we can start to create visualizations is by selecting the specific visualization we want and dragging it onto the canvas. In this case, I'm interested in looking at our sales across the world based on countries. So in this case, I can find country. Alternatively, if I have a lot of data, I can simply start to type at the top and I'll see country comes to the surface. As we said, we wanted to take a look at sales. In this case, we look specifically at country, but as you can see, we can go further down in terms of latitude and longitude. Now with this, I can manually drag and drop to make this as big or as small as I want, and you'll see that we show percentages of how much real estate it's actually taking up. Of course, each of our visualizations has a number of properties. We won't get into those in too much detail, but if there's something that you're looking to do, take a look in the properties and it's likely there. The final way that we'll show creating visualizations is through our assistant. Now in this case, I may have an idea of what I want to look at, or I may not. If I don't, I can simply ask it to suggest questions. This will offer up some insight that I may not have been thinking about. In this case, we'll keep it simple. We'll just look at which product line has the top sales. With a click, I'm now presented with the visualization as well as alternatives based on that particular visualization. If I'm happy with a view, I can simply drag and drop this onto my canvas, and it now becomes a visualization alongside the others. I can continue to resize this. Now, all of our dashboards are designed and meant to be interactive. So in this case, if I were interested in seeing the rest of my dashboard through the specific lens of classic cars, I can click on classic cars and you'll see that all my visualizations are now updating specifically with the filter of classic cars. Now this is one way that I can do it, and I can do it multiple clicks, or alternatively, I can take a particular field and drop it in. If I were perhaps interested in a particular status, I could drag this into the All tabs, or if I just wanted to be specific to this tab, in here. Now with this, I'll be able to choose one or many. In this case, maybe we want to take a look at how much we have in the on hold status. So with that, you'll see again, all of these have been updated to reflect simply the on hold. So it looks like from a worldwide view, we only have holds in a couple of countries, which is positive. In the next video, we'll delve deeper into a few of the more advanced capabilities of the dashboard. In this video, we're going to cover a few of the more advanced capabilities in Cognos Analytics dashboards. We'll cover how to create calculations, how to leverage navigation paths, how to do excludes from visualizations, as well as how to set top-bottom on a visualization. Much like Excel, our dashboard can create calculations. We list out a number of different options here that you can take a look at, or alternatively, you can simply start typing and we'll offer up suggestions. Now in this case, we're interested in looking at our MSRP minus the price that we sell each unit for to give us a margin calculation. Now this calculation is treated exactly the same as any of our other fields that we have in here. So in this case, let's select our margin and we'll look at product line and bring that in. Now in this case, we can see that trains is not doing very well. It's actually a negative margin for us. Now we may want to drill into this a little bit more. So we can create what we call navigation paths. In this case, I can choose any field from my data to be able to drill up and down on. In this case, we want to start with product line, and perhaps we want to see customers, and ultimately if there are specific orders. Now I can right-click on trains, and I can start to drill down. In this case, I can see that we have a few offenders who are in the negatives when we look at this particular field. So if we go ahead and look at something like mini gifts, again, we can drill down a little bit further to see that while they have one which is positive, their other ones are in the negatives. Let's take another look at something a little bit different. So if we were to look at sales by status and by product line. Now in this case, we're still filtered on trains, so we may want to go back and navigate up. In this case, we're still filtered on just trains. So let's unclick that to get back to our initial starting point. Now in this case, we can see that our shipped is really dramatically having an impact on this. So we can go ahead and we can choose to exclude our shipped items. Now we get a much better view of everything else that's going on for the other statuses. Another thing that we could do is if we have a large number of data points, in this case, perhaps customer sales, customer name and sales, we may want to filter down on only our most important ones. So in this case, I can come to sales, right click, and I can ask it to show us a top X number. In this case, by default, we have 10. So now we can see these are our top 10 customers. And one last one just for fun, we can actually create infographics on the fly. So in this case, if I've got sales, I can take any one of my shapes here, perhaps a piggy bank, drop it on top, and just like that, we've now created an infographic.
A type is how Python represents different types of data. In this video, we will discuss some widely used types in Python. You can have different types in Python. They can be integers like 11, real numbers like 21.213. They can even be words. Integers, real numbers, and words can be expressed as different data types. The following chart summarizes 3 data types for the last examples. The first column indicates the expression. The second column indicates the data type. We can see the actual data type in Python by using the type command. We can have int, which stands for an integer, and float that stands for float, essentially a real number. The type string is a sequence of characters. Here are some integers. Integers can be negative or positive. It should be noted that there is a finite range of integers, but it is quite large. Floats are real numbers. They include the integers but also numbers in between the integers. Consider the numbers between 0 and 1. We can select numbers in between them. These numbers are floats. Similarly, consider the numbers between 0.5 and 0.6. We can select numbers in between them. These are floats as well. We can continue the process, zooming in for different numbers. Of course, there is a limit, but it is quite small. You can change the type of the expression in Python. This is called typecasting. You can convert an int to a float. For example, you can convert or cast the integer 2 to a float 2. Nothing really changes. If you cast a float to an integer, you must be careful. For example, if you cast the float 1.1 to 1, you will lose some information. If a string contains an integer value, you can convert it to int. If we convert a string that contains a non-integer value, we get an error. Check out more examples in the lab. You can convert an int to a string, or a float to a string. Boolean is another important type in Python. A Boolean can take on two values. The first value is true. Just remember we use an uppercase T. Boolean values can also be false, with an uppercase F. Using the type command on a Boolean value, we obtain the term bool. This is short for Boolean. If we cast a Boolean true to an integer or float, we will get a 1. If we cast a Boolean false to an integer or float, we get a 0. If you cast a 1 to a Boolean, you get a true. Similarly, if you cast a 0 to a Boolean, you get a false. Check the labs for more examples or check python.org for other kinds of types in Python. In this video, we'll cover expressions and variables. Expressions describe a type of operation that computers perform. Expressions are operations that Python performs. For example, basic arithmetic operations like adding multiple numbers. The result, in this case, is 160. We call the numbers operands, and the math symbols, in this case addition, are called operators. We can perform operations such as subtraction using the subtraction sign. In this case, the result is a negative number. We can perform multiplication operations using the asterisk. The result is 25. In this case, the operands are given by negative and asterisks. We can also perform division with the forward slash. 25 divided by 5 is 5. 25 divided by 6 is approximately 4.167. In Python 3, the version we will be using in this course, both will result in a float. We can use the double slash for integer division, where the result is rounded. Be aware, in some cases, the results are not the same as regular division. Python follows mathematical conventions when performing mathematical expressions. The following operations are in a different order. In both cases, Python performs multiplication, then addition to obtain the final result. There are a lot more operations you can do with Python. Check the labs for more examples. We will also be covering more complex operations throughout the course. The expressions in the parentheses are performed first. We then multiply the result by 60. The result is 1,920. Now let's look at variables. We can use variables to store values. In this case, we assign a value of 1 to the variable my_variable using the assignment operator, i.e. the equal sign. We can then use the value somewhere else in the code by typing the exact name of the variable. We will use a colon to denote the value of the variable. We can assign a new value to my_variable using the assignment operator. We assign a value of 10. The variable now has a value of 10. The old value of the variable is not important. We can store the results of expressions. For example, we add several values and assign the result to x. X now stores the result. We can also perform operations on x and save the result to a new variable y. Y now has a value of 2.666. We could also perform operations on x and assign the value x. The variable x now has a value 2.666. As before, the old value of x is not important. We can use the type command in variables as well. It's good practice to use meaningful variable names, so you don't have to keep track of what the variable is doing. Let's say we would like to convert the number of minutes in the highlighted examples to number of hours in the following music dataset. We call the variable that contains the total number of minutes total_min. It's common to use the underscore to represent the start of a new word. You can also use a capital letter. We call the variable that contains the total number of hours total_hour. We can obtain the total number of hours by dividing total_min by 60. The result is approximately 2.367 hours. If we modify the value of the first variable, the value of the variable will change. The final result values change accordingly, but we do not have to modify the rest of the code. In Python, a string is a sequence of characters. A string is contained within 2 quotes. You can also use single quotes. A string can be spaces or digits. A string can also be special characters. We can bind or assign a string to another variable. It is helpful to think of a string as an ordered sequence. Each element in the sequence can be accessed using an index represented by the array of numbers. The first index can be accessed as follows. We can access index 6. Moreover, we can access the 13th index. We can also use negative indexing with strings. The last element is given by the index -1. The first element can be obtained by index -15, and so on. We can bind a string to another variable. It is helpful to think of string as a list or tuple. We can treat the string as a sequence and perform sequence operations. We can also input a stride value as follows. The 2 indicates we select every second variable. We can also incorporate slicing. In this case, we return every second value up to index 4. We can use the len command to obtain the length of the string. As there are 15 elements, the result is 15. We can concatenate or combine strings. We use the addition symbols. The result is a new string that is a combination of both. We can replicate values of a string. We simply multiply the string by the number of times we would like to replicate it, in this case 3. The result is a new string. The new string consists of 3 copies of the original string. This means you cannot change the value of the string, but you can create a new string. For example, you can create a new string by setting it to the original variable and concatenate it with a new string. The result is a new string that changes from Michael Jackson to Michael Jackson is the best. Strings are immutable. Backslashes represent the beginning of escape sequences. Escape sequences represent strings that may be difficult to input. For example, \n represent a new line. The output is given by a new line after the \n is encountered. Similarly, \t represents a tab. The output is given by a tab where the \t is. If you want to place a backslash in your string, use a double backslash. The result is a backslash after the escape sequence. We can also place an R in front of the string. Now let's take a look at string methods. Strings are sequences, and, as such, have apply methods that work on lists and tuples. Strings also have a second set of methods that just work on strings. When we apply a method to the string A, we get a new string B that is different from A. Let's do some examples. Let's try with the method upper. This method converts lowercase characters to uppercase characters. In this example, we set the variable a to the following value. We apply the method upper and set it equal to b. The value for b is similar to a, but all the characters are uppercase. The method replaces a segment of the string, i.e., a substring, with a new string. We input the part of the string we would like to change. The second argument is what we would like to exchange the segment with. The result is a new string with the segment changed. The method find finds substrings. The argument is the substring you would like to find. The output is the first index of the sequence. We can find the substring Jack. If the substring is not in the string, the output is -1. Check the labs for more examples. In this video, we will cover lists and tuples. These are called compound data types and are one of the key types of data structures in Python. Tuples. Tuples are an ordered sequence. Here is a tuple ratings. Tuples are expressed as comma-separated elements within parentheses. These are values inside the parentheses. In Python, there are different types: strings, integer, float. They can all be contained in a tuple, but the type of the variable is tuple. Each element of a tuple can be accessed via an index. The following table represents the relationship between the index and the elements in the tuple. The first element can be accessed by the name of the tuple followed by a square bracket with the index number, in this case 0. We can access the second element as follows. We can also access the last element. In Python, we can use negative index. The relationship is as follows. The corresponding values are shown here. We can concatenate or combine tuples by adding them. The result is the following, with the following index. If we would like multiple elements from a tuple, we can also slice tuples. For example, if we want the first 3 elements, we use the following command. The last index is 1 larger than the index you want. Similarly, if we want the last 2 elements, we use the following command. Notice how the last index is 1 larger than the length of the tuple? We can use the len command to obtain the length of a tuple. As there are 5 elements, the result is 5. Tuples are immutable, which means we can't change them. To see why this is important, let's see what happens when we set the variable ratings1 to ratings. Let's use the image to provide a simplified explanation of what's going on. Each variable does not contain a tuple, but references the same immutable tuple object. See the Objects and Classes module for more about objects. Let's say we want to change the element at index 2. Because tuples are immutable, we can't. Therefore, ratings1 will not be affected by a change in rating because the tuple is immutable, i.e. we can't change it. We can assign a different tuple to the ratings variable. The variable ratings now references another tuple. As a consequence of immutability, if we would like to manipulate a tuple, we must create a new tuple instead. For example, if we would like to sort a tuple, we use the function sorted. The input is the original tuple. The output is a new sorted list. For more on functions, see our video on functions. A tuple can contain other tuples as well as other complex data types. This is called nesting. We can access these elements using the standard indexing methods. If we select an index with a tuple, the same index convention applies. As such, we can then access values in the tuple. For example, we could access the second element. We can apply this indexing directly to the tuple variable nt. It is helpful to visualize this as a tree. We can visualize this nesting as a tree. The tuple has the following indexes. If we consider indexes with other tuples, we see the tuple at index 2 contains a tuple with 2 elements. We can access those 2 indexes. The same convention applies to index 3. We can access the elements in those tuples as well. We can continue the process. We can even access deeper levels of the tree by adding another square bracket. We can access different characters in the string or various elements in the second tuple contained in the first. Lists are also a popular data structure in Python. Lists are also an ordered sequence. Here is a list L. A list is represented with square brackets. In many respects, lists are like tuples. One key difference is they are mutable. Lists can contain strings, floats, integers. We can nest other lists. We also nest tuples and other data structures. The same indexing conventions apply for nesting. Like tuples, each element of a list can be accessed via an index. The following table represents the relationship between the index and the elements in the list. The first element can be accessed by the name of the list followed by a square bracket with the index number, in this case 0. We can access the second element as follows. We can also access the last element. In Python, we can use a negative index. The relationship is as follows. The corresponding indexes are as follows. We can also perform slicing in lists. For example, if we want the last 2 elements in this list, we use the following command. Notice how the last index is 1 larger than the length of the list? The index conventions for lists and tuples are identical. Check the labs for more examples. We can concatenate or combine lists by adding them. The result is the following. The new list has the following indices. Lists are mutable, therefore we can change them. For example, we apply the method extends by adding a dot followed by the name of the method, then parentheses. The argument inside the parentheses is a new list that we are going to concatenate to the original list. In this case, instead of creating a new list, L1, the original list L is modified by adding 2 new elements. To learn more about methods, check out our video on objects and classes. Another similar method is append. If we apply append instead of extended, we add 1 element to the list. If we look at the index, there is only 1 more element. Index 3 contains the list we appended. Every time we apply a method, the list changes. If we apply extend, we add 2 new elements to the list. The list L is modified by adding 2 new elements. If we append the string A, we further change the list, adding the string A. As lists are mutable, we can change them. For example, we can change the first element as follows. The list now becomes Hard Rock 10 1.2. We can delete an element of a list using the del command. We simply indicate the list item we would like to remove as an argument. For example, if we would like to remove the first element, the result becomes 10 1.2. We can delete the second element. This operation removes the second element of the list. We can convert a string to a list using split. For example, the method split converts every group of characters separated by a space into an element of a list. We can use the split function to separate strings on a specific character, known as a delimiter. We simply pass the delimiter we would like to split on as an argument, in this case a comma. The result is a list. Each element corresponds to a set of characters that have been separated by a comma. When we set one variable, b equal to a, both a and b are referencing the same list. Multiple names referring to the same object is known as aliasing. We know from the list slide that the first element in b is set as hard rock. If we change the first element in a to banana, we get a side effect. The value of b will change as a consequence. A and b are referencing the same list. Therefore, if we change a, list b also changes. If we check the first element of b after changing list a, we get banana instead of hard rock. You can clone list a by using the following syntax. Variable a references one list. Variable b references a new copy or clone of the original list. Now, if you change a, b will not change. We can get more info on list, tuples, and many other objects in Python using the help command. Simply pass in the list, tuple, or any other Python object. See the labs for more things you can do with lists. Let's cover dictionaries in Python. Dictionaries are a type of collection in Python. If you recall, a list has integer indexes. These are like addresses. A list also has elements. A dictionary has keys and values. The key is analogous to the index. They are like addresses, but they don't have to be integers. They are usually characters. The values are similar to the element in a list and contain information. To create a dictionary, we use curly brackets. The keys are the first elements. They must be immutable and unique. Each key is followed by a value separated by a colon. The values can be immutable, mutable, and duplicates. Each key and value pair is separated by a comma. Consider the following example of a dictionary. The album title is the key and the value is the release data. We can use yellow to highlight the keys and leave the values in white. It is helpful to use the table to visualize a dictionary, where the first column represents the keys and the second column represents the values. We can add a few more examples to the dictionary. We can also assign the dictionary to a variable. The key is used to look up the value. We use square brackets. The argument is the key. This outputs the value. Using the key of back in black, this returns the value of 1980. The key the dark side of the moon gives us the value of 1973. Using the key the bodyguard gives us the value 1992, and so on. We can add a new entry to the dictionary as follows. This will add the value 2007 with a new key called graduation. We can delete an entry as follows. This gets rid of the key thriller and its value. We can verify if an element is in the dictionary using the in command as follows. The command checks the keys. If they are in the dictionary, they return a true. If we try the same command with a key that is not in the dictionary, we get a false. In order to see all the keys in a dictionary, we can use the method keys to get the keys. The output is a list-like object with all the keys. In the same way, we can obtain the values using the method values. Check out the labs for more examples and info on dictionaries. Let's cover sets. They are also a type of collection. Sets are a type of collection. This means that like lists and tuples, you can input different Python types. Unlike lists and tuples, they are unordered. This means sets do not record element position. Sets only have unique elements. This means there is only one of a particular element in a set. To define a set, you use curly brackets. You place the elements of a set within the curly brackets. You notice there are duplicate items. When the actual set is created, duplicate items will not be present. You can convert a list to a set by using the function set. This is called typecasting. You simply use the list as the input to the function set. The result will be a list converted to a set. Let's go over an example. We start off with a list. We input the list to the function set. The function set returns a set. Notice how there are no duplicate elements. Let's go over set operations. These can be used to change the set. Consider the set A. Let's represent this set with a circle. If you are familiar with sets, this can be part of a Venn diagram. A Venn diagram is a tool that uses shapes usually to represent sets. We can add an item to a set using the add method. We just put the set name followed by a dot, then the add method. The argument is the new element of the set we would like to add, in this case, in sync. The set A now has in sync as an item. If we add the same item twice, nothing will happen as there can be no duplicates in a set. Let's say we would like to remove in sync from set A. We can also remove an item from a set using the remove method. We just put the set name followed by a dot, then the remove method. The argument is the element of the set we would like to remove, in this case, in sync. After the remove method is applied to the set, set A does not contain the item in sync. You can use this method for any item in the set. We can verify if an element is in the set using the in command as follows. The command checks if the item, in this case ACDC, is in the set. If the item is in the set, it returns true. If we look for an item that is not in the set, in this case for the item who, as the item is not in the set, we will get a false. These are types of mathematical set operations. There are other operations we can do. There are lots of useful mathematical operations we can do between sets. Let's define the set album set 1. We can represent it using a red circle or Venn diagram. Similarly, we can define the set album set 2. We can also represent it using a blue circle or Venn diagram. The intersection of two sets is a new set containing elements which are in both of those sets. It's helpful to use Venn diagrams. The two circles that represent the sets combine. The overlap represents the new set. As the overlap is comprised of the red circle and blue circle, we define the intersection in terms of AND. In Python, we use an ampersand to find the intersection of two sets. If we overlay the values of the set over the circle, placing the common elements in the overlapping area, we see the correspondence. After applying the intersection operation, all the items that are not in both sets disappear. In Python, we simply just place the ampersand between the two sets. We see that both AC/DC and Back in Black are in both sets. The result is a new set album, set 3, containing all the elements in both album set 1 and album set 2. The union of two sets is the new set of elements which contain all the items in both sets. We can find the union of the sets, album set 1 and album set 2, as follows. The result is a new set that has all the elements of album set 1 and album set 2. This new set is represented in green. Consider the new album set 3. The set contains the elements AC/DC and Back in Black. We can represent this with a Venn diagram, as all the elements in album set 3 are in album set 1. The circle representing album set 1 encapsulates the circle representing album set 3. We can check if a set is a subset using the isSubset method. As album set 3 is a subset of the album set 1, the result is true. There is a lot more you can do with sets. Check out the lab for more examples. In this video, you will learn about conditions and branching. Comparison operations compare some value or operand. Then, based on some condition, they produce a Boolean. Let's say we assign a value of a to 6. We can use the equality operator denoted with two equal signs to determine if two values are equal. In this case, if 7 is equal to 6. In this case, as 6 is not equal to 7, the result is false. If we performed an equality test for the value 6, the two values would be equal. As a result, we would get a true. Consider the following equality comparison operator. If the value of the left operand, in this case the variable, I, is greater than the value of the right operand, in this case 5, the condition becomes true, or else we get a false. Let's display some values for I on the left. Let's see the values greater than 5 in green and the rest in red. If we set I equal to 6, we see that 6 is larger than 5, and as a result, we get a true. We can also apply the same operations to floats. If we modify the operator as follows, if the left operand I is greater than or equal to the value of the right operand, in this case 5, then the condition becomes true. In this case, we include the value of 5 in the number line, and the color changes to green accordingly. If we set the value of I equal to 5, the operand will produce a true. If we set the value of I to 2, we would get a false because 2 is less than 5. We can change the inequality if the value of the left operand, in this case I, is less than the value of the right operand, in this case 6. Then condition becomes true. Again, we can represent this with a colored number line. The areas where the inequality is true are marked in green, and red where the inequality is false. If the value for I is set to 2, the result is a true, as 2 is less than 6. The inequality test uses an exclamation mark preceding the equal sign. If two operands are not equal, then the condition becomes true. We can use a number line. When the condition is true, the corresponding numbers are marked in green and red for where the condition is false. If we set I equal to 2, the operator is true as 2 is not equal to 6. We compare strings as well. Comparing AC/DC and Michael Jackson using the equality test, we get a false, as the strings are not the same. Using the inequality test, we get a true, as the strings are different. See the labs for more examples. Branching allows us to run different statements for a different input. It's helpful to think of an if statement as a locked room. If the statement is true, you can enter the room, and your program can run some predefined task. If the statement is false, your program will skip the task. For example, consider the blue rectangle representing an AC/DC concert. If the individual is 18 or older, they can enter the AC/DC concert. If they are under the age of 18, they cannot enter the concert. Individual proceeds to the concert. Their age is 17, therefore they are not granted access to the concert, and they must move on. If the individual is 19, the condition is true. They can enter the concert. Then they can move on. This is the syntax of the if statement from our previous example. We have the if statement. We have the expression that can be true or false. The brackets are not necessary. We have a colon. Within an indent, we have the expression that is run if the condition is true. The statements after the if statement will run regardless if the condition is true or false. For the case where the age is 17, we set the value of the variable age to 17. We check the if statement. The statement is false. Therefore, the program will not execute the statement to print "you will enter." In this case, it will just print "move on." For the case where the age is 19, we set the value of the variable age to 19. We check the if statement. The statement is true. Therefore, the program will execute the statement to print "you will enter." Then it will just print "move on." The else statement will run a different block of code if the same condition is false. Let's use the AC/DC concert analogy again. If the user is 17, they cannot go to the AC/DC concert, but they can go to the Meatloaf concert represented by the purple square. If the individual is 19, the condition is true. They can enter the AC/DC concert. Then they can move on as before. The syntax of the else statement is similar. We simply append the statement else. We then add the expression we would like to execute with an indent. For the case where the age is 17, we set the value of the variable age to 17. We check the if statement. The statement is false. Therefore, we progress to the else statement. We run the statement in the indent. This corresponds to the individual attending the Meatloaf concert. The program will then continue running. For the case where the age is 19, we set the value of the variable age to 19. We check the if statement. The statement is true. Therefore, the program will execute the statement to print "you will enter." The program skips the expressions in the else statement and continues to run the rest of the expressions. The elif statement, short for else if, allows us to check additional conditions if the preceding condition is false. If the condition is true, the alternate expressions will be run. Consider the concert example. If the individual is 18, they will go to the Pink Floyd concert instead of attending the AC/DC or Meatloaf concerts. The person of 18 years of age enters the area as they are not over 19 years of age. They cannot see AC/DC, but as they are 18 years, they attend Pink Floyd. After seeing Pink Floyd, they move on. The syntax of the elif statement is similar. We simply add the statement elif with the condition. We then add the expression we would like to execute if the statement is true, with an indent. Let's illustrate the code on the left. An 18-year-old enters. They are not older than 18 years of age. Therefore, the condition is false. So the condition of the elif statement is checked. The condition is true. So then we would print "go see Pink Floyd." Then we would move on, as before. If the variable age was 17, the statement "go see Meatloaf" would print. Similarly, if the age was greater than 18, the statement "you can enter" would print. Check the labs for more examples. Now let's take a look at logic operators. Logic operations take Boolean values and produce different Boolean values. The first operation is the not operator. If the input is true, the result is a false. Similarly, if the input is false, the result is a true. Let A and B represent Boolean variables. The OR operator takes in the two values and produces a new Boolean value. We can use this table to represent the different values. The first column represents the possible values of A. The second column represents the possible values of B. The final column represents the result of applying the OR operation. We see the OR operator only produces a false if all the Boolean values are false. The following lines of code will print out. This album was made in the 70s or 90s, if the variable album year does not fall in the 80s. Let's see what happens when we set the album year to 1990. The colored number line is green when the condition is true, and red when the condition is false. In this case, the condition is false. Examining the second condition, we see that 1990 is greater than 1989, so the condition is true. We can verify by examining the corresponding second number line. In the final number line, the green region indicates where the area is true. This region corresponds to where at least one statement is true. We see that 1990 falls in the area. Therefore, we execute the statement. Let A and B represent Boolean variables. The AND operator takes in the two values and produces a new Boolean value. We can use this table to represent the different values. The first column represents the possible values of A. The second column represents the possible values of B. The final column represents the result of applying the AND operation. We see the AND operator only produces a true if all the Boolean values are true. The following lines of code will print out. This album was made in the 80s if the variable album year is between 1980 and 1989. Let's see what happens when we set the album year to 1983. As before, we can use the colored number line to examine where the condition is true. In this case, 1983 is larger than 1980, so the condition is true. Examining the second condition, we see that 1990 is greater than 1983, so this condition is also true. We can verify by examining the corresponding second number line. In the final number line, the green region indicates where the area is true. Similarly, this region corresponds to where both statements are true. We see that 1983 falls in the area. Therefore, we execute the statement. Branching allows us to run different statements for different inputs. In this video, we will cover loops, in particular for loops and while loops. We will use many visual examples in this video. See the labs for examples with data. Before we talk about loops, let's go over the range function. The range function outputs an ordered sequence as a list I. If the input is a positive integer, the output is a sequence. The sequence contains the same number of elements as the input, but starts at 0. For example, if the input is 3, the output is the sequence 0, 1, 2.
If the range function has two inputs, where the first input is smaller than the second input, the output is a sequence that starts at the first input.
Then the sequence iterates up to, but not including the second number. For the input 10 and 15, we get the following sequence. See the labs for more capabilities of the range function. Please note, if you use Python 3, the range function will not generate a list explicitly like in Python 2. In this section, we will cover for loops. We will focus on lists, but many of the procedures can be used on tuples. Loops perform a task over and over. Consider the group of colored squares. Let's say we would like to replace each colored square with a white square. Let's give each square a number to make things a little easier and refer to all the group of squares as squares. If we wanted to tell someone to replace square 0 with a white square, we would say equals replace square 0 with a white square. Or we can say for square 0 in squares, square 0 equals white square. Similarly, for the next square, we can say for square 1 in squares, square 1 equals white square. For the next square, we can say for square 2 in squares, square 2 equals white square. We repeat the process for each square. The only thing that changes is the index of the square we are referring to. If we are going to perform a similar task in Python, we cannot use actual squares. So let's use a list to represent the boxes. Each element in the list is a string representing the color. We want to change the name of the color in each element to white. Each element in the list has the following index. This is a syntax to perform a loop in Python. Notice the indent. The range function generates a list. The code will simply repeat everything in the indent 5 times. If you were to change the value to 6, it would do it 6 times. However, the value of I is incremented by 1 each time. In this segment, we change the ith element of the list to the string white. The value of I is set to 0. Each iteration of the loop starts at the beginning of the indent. We then run everything in the indent. The first element in the list is set to white. We then go to the start of the indent. We progress down each line. When we reach the line to change the value of the list, we set the value of index 1 to white. The value of I increases by 1. We repeat the process for index 2. The process continues for the next index until we have reached the final element. We can also iterate through a list or tuple directly in Python. We do not even need to use indices. Here is the list squares. Each iteration of the list we pass one element of the list squares to the variable square. Let's display the value of the variable square on this section. For the first iteration, the value of square is red. We then start the second iteration. For the second iteration, the value of square is yellow. We then start the third iteration. For the final iteration, the value of square is green. A useful function for iterating data is enumerate. It can be used to obtain the index and the element in the list. Let's use the box analogy with the numbers representing the index of each square. This is the syntax to iterate through a list and provide the index of each element. We use the list squares and use the names of the colors to represent the colored squares. The argument of the function enumerate is the list, in this case squares. The variable I is the index, and the variable square is the corresponding element in the list. Let's use the left part of the screen to display the different values of the variable square, and I for the various iterations of the loop. For the first iteration, the value of the variable is red, corresponding to the 0th index, and the value for I is 0. For the second iteration, the value of the variable square is yellow, and the value of I corresponds to its index, i.e. 1. We repeat the process for the last index. While loops are similar to for loops, but instead of executing a statement a set number of times, a while loop will only run if a condition is met. Let's say we would like to copy all the orange squares from the list squares to the list new squares, but we would like to stop if we encounter a non-orange square. We don't know the value of the squares beforehand. We would simply continue the process while the square is orange, or see if the square equals orange. If not, we would stop. For the first example, we would check if the square was orange. It satisfies the condition, so we would copy the square. We repeat the process for the second square. The condition is met, so we copy the square. In the next iteration, we encounter a purple square. The condition is not met, so we stop the process. This is essentially what a while loop does. Let's use the figure on the left to represent the code. We will use a list with the names of the color to represent the different squares. We create an empty list of new squares. In reality, the list is of indeterminate size. We start the index at 0. The while statement will repeatedly execute the statements within the indent until the condition inside the bracket is false. We append the value of the first element of the list squares to the list new squares. We increase the value of I by 1. We append the value of the second element of the list squares to the list new squares. We increment the value of I. Now the value in the array squares is purple. Therefore, the condition for the while statement is false, and we exit the loop. Check out the labs for more examples of loop, many with real data. In this video, we will cover functions. You will learn how to use some of Python's built-in functions as well as how to build your own function. Functions take some input, then produce some output or change. The function is just a piece of code you can reuse. You can implement your own function, but in many cases you use other people's functions. In this case, you just have to know how the function works, and in some cases, how to import the functions. Let the orange and yellow squares represent similar blocks of code. We can run the code using some input and get an output. If we define a function to do the task, we just have to call the function. Let the small squares represent the lines of code used to call the function. We can replace these long lines of code by just calling the function a few times. Now we can just call the function. Our code is much shorter. The code performs the same task. You can think of the process like this. When we call the function f1, we pass an input to the function. These values are passed to all those lines of code you wrote. This returns a value. You can use the value. For example, you can input this value to a new function, f2. When we call this new function f2, the value is passed to another set of lines of code. The function returns a value. The process is repeated, passing the values to the function you call. You can save these functions and reuse them, or use other people's functions. Python has many built-in functions. You don't have to know how those functions work internally, but simply what task those functions perform. The function len takes in an input of type sequence, such as a string or list, or type collection, such as a dictionary or set, and returns the length of that sequence or collection. Consider the following list. The len function takes this list as an argument, and we assign the result to the variable L. The function determines there are 8 items in the list, then returns the length of the list, in this case 8. The function sum takes in an iterable like a tuple or list and returns the total of all the elements. Consider the following list. We pass the list into the sum function and assign the result to the variable s. The function determines the total of all the elements, then returns it. In this case, the value is 70. There are 2 ways to sort a list. The first is using the function sorted. We can also use the list method sort. Methods are similar to functions. Let's use this as an example to illustrate the difference. The function sorted returns a new sorted list or tuple. Consider the list album ratings. We can apply the function sorted to the list album ratings and get a new list sorted album rating. The result is a new sorted list. If we look at the list album ratings, nothing has changed. Generally, functions take an input, in this case a list. They produce a new output, in this instance a sorted list. If we use the method sort, the list album ratings will change and no new list will be created. Let's use the diagram to help illustrate the process. In this case, the rectangle represents the list album ratings. When we apply the method sort to the list album rating changes. Unlike the previous case, we see that the list album rating has changed. In this case, no new list is created. Now that we've gone over how to use functions in Python, let's see how to build our own functions. We will now get you started on building your own functions in Python. This is an example of a function in Python that returns its input value +1. To define a function, we start with the keyword def. The name of the function should be descriptive of what it does. We have the function formal parameter a in parentheses, followed by a colon. We have a code block with an indent. For this case, we add 1 to a and assign it to b. We return or output the value for b. After we define the function, we can call it. The function will add 1 to 5 and return a 6. We can call the function again, this time assign it to the variable c. The value for c is 11. Let's explore this further. Let's go over an example when you call a function. It should be noted that this is a simplified model of Python, and Python does not work like this under the hood. We call the function giving it an input 5. It helps to think of the value of 5 as being passed to the function. Now the sequences of commands are run. The value of a is 5. B would be assigned a value of 6. We then return the value of b. In this case, as b was assigned a value of 6, the function returns a 6. If we call the function again, the process starts from scratch. We pass in an 8. The subsequent operations are performed. Everything that happened the last call will happen again with a different value of a. The function returns a value, in this case 9. Again, this is just a helpful analogy. Let's try and make this function more complex. It's customary to document the function on the first few lines. This tells anyone who uses the function what it does. This documentation is surrounded in triple quotes. You can use the help command on the function to display the documentation as follows. This will print out the function name and the documentation. We will not include the documentation in the rest of the examples. A function can have multiple parameters. The function mult multiplies 2 numbers. In other words, it finds their product. If we pass the integers 2 and 3, the result is a new integer. If we pass the integer 10 and the float 3.14, the result is a float 31.4. If we pass in the integer 2 and the string Michael Jackson, the string Michael Jackson is repeated 2 times. This is because the multiplication symbol can also mean repeat a sequence. If you accidentally multiply an integer with a string instead of 2 integers, you won't get an error. Instead, you will get a string, and your program will progress, potentially failing later because you have a string where you expected an integer. This property will make coding simpler, but you must test your code more thoroughly. In many cases, a function does not have a return statement. In these cases, Python will return the special none object. Practically speaking, if your function has no return statement, you can treat it as if the function returns nothing at all. The function mj simply prints the name Michael Jackson. We call the function. The function prints Michael Jackson. Let's define the function noWork that performs no task. Python doesn't allow a function to have an empty body, so we can use the keyword pass, which doesn't do anything but satisfies the requirement of a non-empty body. If we call the function and print it out, the function returns a none. In the background, if the return statement is not called, Python will automatically return a none. It is helpful to view the function noWork with the following return statement. Usually functions perform more than one task. This function prints a statement then returns a value. Let's use this table to represent the different values as the function is called. We call the function with an input of 2. We find the value of b. The function prints the statement with the value of a and b. Finally, the function returns the value of b, in this case 3. We can use loops in functions. This function prints out the values and indexes of a loop or tuple. We call the function with the list album ratings as an input. Let's display the list on the right with its corresponding index. Stuff is used as an input to the function enumerate. This operation will pass the index to I and the value in the list to S. The function would begin to iterate through the loop. The function will print the first index and the first value in the list. We continue iterating through the loop. The values of I and S are updated. The print statement is reached. Similarly, the next values of the list and index are printed. The process is repeated. The values of I and S are updated. We continue iterating until the final values in the list are printed out. Variadic parameters allow us to input a variable number of elements. Consider the following function. The function has an asterisk on the parameter names. When we call the function, 3 parameters are packed into the tuple names. We then iterate through the loop. The values are printed out accordingly. If we call the same function with only 2 parameters as inputs, the variable names only contain 2 elements. The result is only 2 values are printed out. The scope of a variable is the part of the program where that variable is accessible. Variables that are defined outside of any function are said to be within the global scope, meaning they can be accessed anywhere after they are defined. Here we have a function that adds the string dc to the parameter x. When we reach the part where the value of x is set to ac, this is within the global scope, meaning x is accessible anywhere after it is defined. A variable defined in the global scope is called a global variable. When we call the function, we enter a new scope or the scope of addDC. We pass as an argument to the addDC function, in this case AC. Within the scope of the function, the value of x is set to ACDC. The function returns the value and is assigned to z. Within the global scope, the value z is set to ACDC. After the value is returned, the scope of the function is deleted. Local variables only exist within the scope of a function. Consider the function thriller. The local variable date is set to 1982. When we call the function, we create a new scope. Within that scope of the function, the value of the date is set to 1982. The value of date does not exist within the global scope. Variables inside the global scope can have the same name as variables in the local scope, with no conflict. Consider the function thriller. The local variable date is set to 1982. The global variable date is set to 2017. When we call the function, we create a new scope. Within that scope, the value of the date is set to 1982. If we call the function, it returns the value of date in the local scope, in this case 1982. When we print in the global scope, we use the global variable value. The global value of the variable is 2017. Therefore, the value is set to 2017. If a variable is not defined within a function, Python will check the global scope. Consider the function ACDC. The function has the variable rating with no value assigned. If we define the variable rating in the global scope, then call the function, Python will see there is no value for the variable rating. As a result, Python will leave the scope and check if the variable ratings exists in the global scope. It will use the value of ratings in the global scope within the scope of ACDC. In the function, we'll print out a 9. The value of z in the global scope will be 10, as we added 1. The value of rating will be unchanged within the global scope. Consider the function Pink Floyd. If we define the variable claimed sales with the keyword global, the variable will be a global variable. We call the function Pink Floyd. The variable claimed sales is set to the string 45 million in the global scope. When we print the variable, we get a value of 45 million. There is a lot more you can do with functions. Check out the lab for more examples.
Hello and welcome to Exception Handling. After watching this video, you will be able to explain exception handling, demonstrate the use of exception handling, and understand the basics of exception handling. Have you ever mistakenly entered a number when you were supposed to enter text in an input field? Most of us have, either in error or when testing out a program. But do you know why it gave an error message instead of completing and terminating the program? In order for the error message to appear, an event was triggered in the background. This event was activated because the program tried to perform a computation on the name entry and realized the entry contained numbers and not letters. By encasing this code in an exception handler, the program knew how to deal with this type of error and was able to output the error message to continue with the program. This is one of many errors that can happen when asking for user input. So let us see how exception handling works. We will first explore the try except statement. This type of statement will first attempt to execute the code in the try block. But if an error occurs, it will kick out and begin searching for the exception that matches the error. Once it finds the correct exception to handle the error, it will then execute that line of code. For example, perhaps you are writing a program that will open and write a file. After starting the program, an error occurred as the data was not able to be read. Because of this error, the program skipped over the code lines under the try statement and went directly to the exception line. Since this error fell within the I/O error guidelines, it printed unable to open or read the data in the file to our console. When writing simple programs, we can sometimes get away with only one except statement. But what happens if another error occurs that is not caught by the I/O error? If that happened, we would need to add another except statement. For this except statement, you will notice that the type of error to catch is not specified. While this may seem a logical step so the program will catch all errors and not terminate, this is not a best practice. For example, perhaps our small program was just one section of a much larger program that was over 1,000 lines of code. Our task was to debug the program as it kept throwing an error causing a disruption for our users. When investigating the program, you found this error kept appearing. Because this error had no details, you ended up spending hours trying to pinpoint and fix the error. So far in our program, we have defined that an error message should print out if an error occurs, but we do not receive any messages that the program executed properly. This is where we can now add an else statement to give us that notification. By adding this else statement, it will provide us a notification to the console that the file was written successfully. Now that we have defined what will happen if our program executes properly, or if an error occurs, there is one last statement to add. For this example, since we are opening a file, the last thing we need to do is close the file. By adding a finally statement, it will tell the program to close the file no matter the end result, and print "File is now closed" to our console. In this video, you learned how to write a try-except statement, why it is important to always define errors when creating exceptions, and how to add an else and finally statement.
In this module, we are going to talk about objects and classes. Python has many different kinds of data types: integers, floats, strings, lists, dictionaries, booleans. In Python, each is an object. Every object has the following: a type, internal representation, a set of functions called methods to interact with the data. An object is an instance of a particular type. For example, we have two types, type 1 and type 2. We can have several objects of type 1 as shown in yellow. Each object is an instance of type 1. We also have several objects of type 2 shown in green. Each object is an instance of type 2. Let's do several less abstract examples. Every time we create an integer, we are creating an instance of type integer, or we are creating an integer object. In this case, we are creating 5 instances of type integer or 5 integer objects. Similarly, every time we create a list, we are creating an instance of type list, or we are creating a list object. In this case, we are creating 5 instances of type list or 5 list objects. We can find out the type of an object by using the type command. In this case, we have an object of type list. We have an object of type integer. We have an object of type string. Finally, we have an object of type dictionary. A class or type's methods are functions that every instance of that class or type provides. It's how you interact with the object. We have been using methods all this time, for example, on lists. Sorting is an example of a method that interacts with the data in the object. Consider the list ratings. The data is a series of numbers contained within the list. The method sort will change the data within the object. We call the method by adding a period at the end of the object's name, and the method's name we would like to call with parentheses. We have the ratings list represented in orange. The data contained in the list is a sequence of numbers. We call the sort method. This changes the data contained in the object. You can say it changes the state of the object. We can call the reverse method on the list, changing the list again. We call the method reversing the order of the sequence within the object. In many cases, you don't have to know the inner workings of the class and its methods. You just have to know how to use them. Next, we will cover how to construct your own classes. You can create your own type or class in Python. In this section, you will create a class. The class has data attributes. The class has methods. We then create instances of that class or objects. The class data attributes define the class. Let's create 2 classes. The first class will be a circle. The second will be a rectangle. Let's think about what constitutes a circle. Examining this image, all we need is a radius to define a circle, and let's add color to make it easier to distinguish between different instances of the class later. Therefore, our class data attributes are radius and color. Similarly, examining the image in order to define a rectangle, we need the height and width. We will also add color to distinguish between instances later. Therefore, the data attributes are color, height, and width. To create the class circle, you will need to include the class definition. This tells Python you are creating your own class, the name of the class. For this course in parentheses, you will always place the term object. This is the parent of the class. For the class rectangle, we change the name of the class, but the rest is kept the same. Classes are outlines we have to set the attributes to create objects. We can create an object that is an instance of type circle. The color data attribute is red, and the data attribute radius is 4. We can also create a second object that is an instance of type circle. In this case, the color data attribute is green, and the data attribute radius is 2. We can also create an object that is an instance of type rectangle. The color data attribute is blue, and the data attribute of height and width is 2. The second object is also an instance of type rectangle. In this case, the color data attribute is yellow, and the height is 1, and the width is 3. We now have different objects of class circle or type circle. We also have different objects of class rectangle or type rectangle. Let us continue building the circle class in Python. We define our class. We then initialize each instance of the class with data attributes, radius, and color using the class constructor. The function init is a constructor. It's a special function that tells Python you are making a new class. There are other special functions in Python to make more complex classes. The radius and color parameters are used to initialize the radius and color data attributes of the class instance. The self parameter refers to the newly created instance of the class. The parameters radius and color can be used in the constructor's body to access the values passed to the class constructor when the class is constructed. We can set the value of the radius and color data attributes to the values passed to the constructor method. Similarly, we can define the class rectangle in Python. The name of the class is different. This time, the class data attributes are color, height, and width. After we have created the class, in order to create an object of class circle, we introduce a variable. This will be the name of the object. We create the object by using the object constructor. The object constructor consists of the name of the class, as well as the parameters. These are the data attributes. When we create a circle object, we call the code like a function. The arguments passed to the circle constructor are used to initialize the data attributes of the newly created circle instance. It is helpful to think of self as a box that contains all the data attributes of the object. Typing the object's name followed by a dot and the data attribute name gives us the data attribute value, for example, radius. In this case, the radius is 10. We can do the same for color. We can see the relationship between the self parameter and the object. In Python, we can also set or change the data attribute directly, typing the object's name followed by a dot and the data attribute name, and set it equal to the corresponding value. We can verify that the color data attribute has changed. Usually, in order to change the data in an object, we define methods in the class. Let's discuss methods. We have seen how data attributes consist of the data defining the objects. Methods are functions that interact and change the data attributes, changing or using the data attributes of the object. Let's say we would like to change the size of a circle. This involves changing the radius attribute. We add a method addRadius to the class circle. The method is a function that requires the self as well as other parameters. In this case, we are going to add a value to the radius. We denote that value as r. We are going to add r to the data attribute radius. Let's see how this part of the code works when we create an object and call the addRadius method. As before, we create an object with the object constructor. We pass 2 arguments to the constructor. The radius is set to 2 and the color is set to red. In the constructor's body, the data attributes are set. We can use the box analogy to see the current state of the object. We call the method by adding a dot followed by the method name in parentheses. In this case, the argument of the function is the amount we would like to add. We do not need to worry about the self parameter when calling the method. Just like with the constructor, Python will take care of that for us. In many cases, there may not be any parameters other than self specified in the method's definition, so we don't pass any arguments when calling the function. Internally, the method is called with a value of 8 and the proper self object. The method assigns a new value to self.radius. This changes the object, in particular the radius data attribute. When we call the addRadius method, this changes the object by changing the value of the radius data attribute. We can add default values to the parameters of a class's constructor. In the labs, we also create the method called drawCircle. See the lab for the implementation of drawCircle. In the labs, we can create a new object of type circle using the constructor. The color will be red and the radius will be 3. We can access the data attribute radius. We can access the attribute color. Finally, we can use the method drawCircle to draw the circle. Similarly, we can create a new object of type circle. We can access the data attribute of radius. We can access the data attribute color. We can use the method drawCircle to draw the circle. In summary, we have created an object of class circle called redCircle with a radius attribute of 3 and a color attribute of red. We also created an object of class circle called blueCircle with a radius attribute of 10 and a color attribute of blue. In the lab, we have a similar class for rectangle. We can create a new object of type rectangle using the constructor. We can access a data attribute of height. We can also access the data attribute of width. We can do the same for the data attribute of color. We can use the method drawRectangle to draw the rectangle. So we have a class, an object that is a realization or instantiation of that class. For example, we can create two objects of class circle or two objects of class rectangle. The dir function is useful for obtaining the list of data attributes and methods associated with a class. The object you're interested in is passed as an argument. The return value is a list of that object's data attributes. The attributes surrounded by underscores are for internal use, and you shouldn't have to worry about them. The regular-looking attributes are the ones you should concern yourself with. These are the object's methods and data attributes. There is a lot more you can do with objects in Python. Check python.org for more info. In this section, we will use Python's built-in open function to create a file object and obtain the data from a txt file. We will use Python's open function to get a file object. We can apply a method to that object to read data from the file. We can open the file example1.txt as follows. We use the open function. The first argument is the file path. This is made up of the file name and the file directory. The second parameter is the mode. Common values used include R for reading, W for writing, and A for appending. We will use R for reading. Finally, we have the file object. We can now use the file object to obtain information about the file. We can use the data attribute name to get the name of the file. The result is a string that contains the name of the file. We can see what mode the object is in using the data attribute mode, and R is shown representing read. You should always close the file object using the method close. This may get tedious sometimes, so let's use the with statement. Using a with statement to open the file is better practice because it automatically closes the file. The code will run everything in the indent block, then closes the file. This code reads the file example1.txt. We can use the file object file1. The code will perform all operations in the indent block, then close the file at the end of the indent. The method read stores the values of the file in the variable file_stuff as a string. You can print the file content. You can check if the file content is closed, but you cannot read from it outside the indent. But you can print the file content outside the indent as well. We can print the file content. We will see the following. When we examine the raw string, we will see the /n. This is so Python knows to start a new line. We can output every line as an element in a list using the method readLines. The first line corresponds to the first element in the list. The second line corresponds to the second element in the list, and so on. We can use the method readLine to read the first line of the file. If we run this command, it will store the first line in the variable file_stuff, then print the first line. We can use the method readLine twice. The first time it's called, it will save the first line in the variable file_stuff, and then print the first line. The second time it's called, it will save the second line in the variable file_stuff, and then print the second line. We can use a loop to print out each line individually as follows. Let's represent every character in a string as a grid. We can specify the number of characters we would like to read from a string as an argument to the method readLines. When we use a 4 as an argument in the method readLines, we print out the first 4 characters in the file. Each time we call the method, we will progress through the text. If we call the method with the argument 16, the first 16 characters are printed out and then the new line. If we call the method a second time, the next 5 characters are printed out. Finally, if we call the method the last time with the argument 9, the last 9 characters are printed out. Check out the labs for more examples of methods and other file types. We can also write to files using the open function. We will use Python's open function to get a file object, to create a text file. We can apply method write to write data to that file. As a result, text will be written to the file. We can create the file example2.txt as follows. We use the open function. The first argument is the file path. This is made up of the file name. If you have that file in your directory, it will be overwritten, and the file directory. We set the mode parameter to W for writing. Finally, we have the file object. As before, we use the with statement. The code will run everything in the indent block, then close the file. We create the file object, file1. We use the open function. This creates a file example2.txt in your directory. We use the method write to write data into the file. The argument is the text we would like input into the file. If we use the write method successively, each time it's called, it will write to the file. The first time it is called, we will write, "This is line A" with a /n to represent a new line. The second time we call the method, it will write, "This is line B," then it will close the file. We can write each element in a list to a file. As before, we use a with command and the open function to create a file. The list lines has 3 elements consisting of text. We use a for loop to read each element of the first lines and pass it to the variable line. The first iteration of the loop writes the first element of the list to the file example2. The second iteration writes the second element of the list, and so on. At the end of the loop, the file will be closed. We can set the mode to appended using a lowercase a. This will not create a new file, but just use the existing file. If we call the method write, it will just write to the existing file, then add "This is line C," then close the file. We can copy one file to a new file as follows. First, we read the file example1 and interact with it via the file object, read file. Then we create a new file example3 and use the file object, write file to interact with it. The for loop takes a line from the file object, read file, and stores it in the file example3 using the file object, write file. The first iteration copies the first line. The second iteration copies the second line till the end of the file is reached. Then both files are closed. Check out the labs for more examples. Dependencies or libraries are pre-written code to help solve problems. In this video, we will introduce Pandas, a popular library for data analysis. We can import the library or a dependency like Pandas using the following command. We start with the import command, followed by the name of the library. We now have access to a large number of pre-built classes and functions. This assumes the library is installed. In our lab environment, all the necessary libraries are installed. Let's say we would like to load a CSV file using the Pandas built-in function, read CSV. A CSV is a typical file type used to store data. We simply type the word pandas, then a dot and the name of the function with all the inputs. Typing pandas all the time may get tedious. We can use the as statement to shorten the name of the library. In this case, we use the standard abbreviation PD. Now we type PD and a dot followed by the name of the function we would like to use. In this case, read_CSV. We are not limited to the abbreviation PD. In this case, we use the term banana. We will stick with PD for the rest of this video. Let's examine this code more in depth. One way Pandas allows you to work with data is with a data frame. Let's go over the process to go from a CSV file to a data frame. This variable stores the path of the CSV. It is used as an argument to the read_CSV function. The result is stored to the variable df. This is short for data frame. Now that we have the data in a data frame, we can work with it. We can use the method head to examine the first 5 rows of a data frame. The process for loading an Excel file is similar. We use the path of the Excel file. The function reads Excel. The result is a data frame. A data frame is comprised of rows and columns. We can create a data frame out of a dictionary. The keys correspond to the column labels. The values are lists corresponding to the rows. We then cast the dictionary to a data frame using the function dataFrame. We can see the direct correspondence between the table. The keys correspond to the table headers. The values are lists corresponding to the rows. We can create a new data frame consisting of 1 column. We just put the data frame name, in this case DF, and the name of the column header enclosed in double brackets. The result is a new data frame comprised of the original column. You can do the same thing for multiple columns. We just put the data frame name, in this case DF, and the name of the multiple column headers enclosed in double brackets. The result is a new data frame comprised of the specified columns. When we have a data frame, we can work with the data and save the results in other formats. Consider the stack of 13 blocks of different colors. We can see there are 3 unique colors. Let's say you would like to find out how many unique elements are in a column of a data frame. This may be much more difficult because instead of 13 elements, you may have millions. Pandas has the method unique to determine the unique elements in a column of a data frame. Let's say we would like to determine the unique year of the albums in the data set. We enter the name of the data frame, then enter the name of the column released within brackets. Then we apply the method unique. The result is all of the unique elements in the column released. Let's say we would like to create a new database consisting of songs from the 1980s and after. We can look at the column released for songs made after 1979, then select the corresponding rows. We can accomplish this within 1 line of code in Pandas, but let's break up the steps. We can use the inequality operators for the entire data frame in Pandas. The result is a series of Boolean values. For our case, we simply specify the column released and the inequality for the albums after 1979. The result is a series of Boolean values. The result is true when the condition is true and false otherwise. We can select the specified columns in 1 line. We simply use the data frame's names, and in square brackets we place the previously mentioned inequality and assign it to the variable df1. We now have a new data frame, where each album was released after 1979. We can save the new data frame using the method to_CSV. The argument is the name of the CSV file. Make sure you include a .csv extension. There are other functions to save the data frame in other formats. In this video, we will be covering NumPy in 1D, in particular ND arrays. NumPy is a library for scientific computing. It has many useful functions. There are many other advantages like speed and memory. NumPy is also the basis for Pandas, so check out our Pandas video. In this video, we will be covering the basics and array creation, indexing and slicing, basic operations, universal functions. Let's go over how to create a NumPy array. A Python list is a container that allows you to store and access data. Each element is associated with an index. We can access each element using a square bracket as follows. A NumPy array, or ND array, is similar to a list. It's usually fixed in size, and each element is of the same type, in this case integers. We can cast a list to a NumPy array by first importing NumPy. We then cast the list as follows. We can access the data via an index. As with the lists, we can access each element with an integer and a square bracket. The value of A is stored as follows. If we check the type of the array, we get numpy.ndArray. As NumPy arrays contain data of the same type, we can use the attribute D type to obtain the data type of the array's elements, in this case a 64-bit integer. Let's review some basic array attributes using the array A. The attribute size is the number of elements in the array. As there are 5 elements, the result is 5. The next 2 attributes will make more sense when we get to higher dimensions, but let's review them. The attribute ndim represents the number of array dimensions or the rank of the array, in this case 1. The attribute shape is a tuple of integers indicating the size of the array in each dimension. We can create a NumPy array with real numbers. When we check the type of the array, we get numpy.ndArray. If we examine the attribute dType, we see float64 as the elements are not integers. There are many other attributes. Check out numpy.org. Let's review some indexing and slicing methods. We can change the first element of the array to 100 as follows. The array's first value is now 100. We can change the 5th element of the array as follows. The 5th element is now 0. Like lists and tuples, we can slice a NumPy array. The elements of the array correspond to the following index. We can select the elements from 1 to 3 and assign it to a new NumPy array, D, as follows. The elements in D correspond to the index. Like lists, we do not count the element corresponding to the last index. We can assign the corresponding indices to new values as follows. The array C now has new values. See the labs or numpy.org for more examples of what you can do with NumPy. NumPy makes it easier to do many operations that are commonly performed in data science. These same operations are usually computationally faster and require less memory in NumPy compared to regular Python. Let's review some of these operations on one-dimensional arrays. We will look at many of the operations in the context of Euclidean vectors to make things more interesting. Vector addition is a widely used operation in data science. Consider the vector U with 2 elements. The elements are distinguished by the different colors. Similarly, consider the vector V with 2 components. In vector addition, we create a new vector, in this case Z. The first component of Z is the addition of the first component of vectors U and V. Similarly, the second component is the sum of the second components of U and V. This new vector Z is now a linear combination of the vector U and V. Representing vector addition with line segment or arrows is helpful. The first vector is represented in red. The vector will point in the direction of the 2 components. The first component of the vector is 1. As a result, the arrow is offset 1 unit from the origin in the horizontal direction. The second component is 0. We represent this component in the vertical direction. As this component is 0, the vector does not point in the vertical direction. We represent the second vector in blue. The first component is 0. Therefore, the arrow does not point to the horizontal direction. The second component is 1. As a result, the vector points in the vertical direction 1 unit. When we add the vector U and V, we get the new vector Z. We add the first component. This corresponds to the horizontal direction. We also add the second component. It's helpful to use the tip-to-tail method when adding vectors, placing the tail of a vector V on the tip of vector U. The new vector Z is constructed by connecting the base of the first vector U with the tail of the second V. The following 3 lines of code will add the 2 lists and place the result in the list Z. We can also perform vector addition with 1 line of NumPy code. It would require multiple lines to perform vector subtraction on 2 lists as shown on the right side of the screen. In addition, the NumPy code will run much faster. This is important if you have lots of data. We can also perform vector subtraction by changing the addition sign to a subtraction sign. It would require multiple lines to perform vector subtraction on 2 lists, as shown on the right side of the screen. Vector multiplication with a scalar is another commonly performed operation. Consider the vector y. Each component is specified by a different color. We simply multiply the vector by a scalar value, in this case 2. Each component of the vector is multiplied by 2. In this case, each component is doubled. We can use the line segment or arrows to visualize what's going on. The original vector y is in purple. After multiplying it by a scalar value of 2, the vector is stretched out by 2 units, as shown in red. The new vector is twice as long in each direction. Vector multiplication with a scalar only requires one line of code using NumPy. It would require multiple lines to perform the same task as shown with Python lists as shown on the right side of the screen. In addition, the operation would also be much slower. Hadamard product is another widely used operation in data science. Consider the following two vectors, u and v. The Hadamard product of u and v is a new vector z. The first component of z is the product of the first element of u and v. Similarly, the second component is the product of the second element of u and v. The resultant vector consists of the entry-wise product of u and v. We can also perform Hadamard product with one line of code in NumPy. It would require multiple lines to perform Hadamard product on two lists as shown on the right side of the screen. The dot product is another widely used operation in data science. Consider the vector u and v. The dot product is a single number given by the following term and represents how similar two vectors are. We multiply the first component from v and u. We then multiply the second component and add the result together. The result is a number that represents how similar the two vectors are. We can also perform dot product using the NumPy function dot and assign it with the variable result as follows. Consider the array u. The array contains the following elements. If we add a scalar value to the array, NumPy will add that value to each element. This property is known as broadcasting. A universal function is a function that operates on ND arrays. We can apply a universal function to a NumPy array. Consider the arrays A. We can calculate the mean or average value of all the elements in A using the method mean. This corresponds to the average of all the elements. In this case, the result is 0. There are many other functions. For example, consider the NumPy arrays B. We can find the maximum value using the method 5. We see the largest value is 5. Therefore, the method max returns a 5. We can use NumPy to create functions that map NumPy arrays to new NumPy arrays. Let's implement some code on the left side of the screen and use the right side of the screen to demonstrate what's going on. We can access the value of pi in NumPy as follows. We can create the following NumPy array in radians. This array corresponds to the following vector. We can apply the function sine to the array x and assign the values to the array y. This applies the sine function to each element in the array. This corresponds to applying the sine function to each component of the vector. The result is a new array y, where each value corresponds to a sine function being applied to each element in the array x. A useful function for plotting mathematical functions is line space. Line space returns evenly spaced numbers over a specified interval. We specify the starting point of the sequence, the ending point of the sequence. The parameter num indicates the number of samples to generate. In this case, 5. The space between samples is 1. If we change the parameter num to 9, we get 9 evenly spaced numbers over the interval from -2 to 2. The result is the difference between subsequent samples is 0.5 as opposed to 1 as before. We can use the function line space to generate 100 evenly spaced samples from the interval 0 to 2 pi. We can use the NumPy function sine to map the array x to a new array y. We can import the library pyplot as plt to help us plot the function. As we are using a Jupyter notebook, we use the command matplotlib inline to display the plot. The following command plots a graph. The first input corresponds to the values for the horizontal or x-axis. The second input corresponds to the values for the vertical or y-axis. There's a lot more you can do with NumPy. Check out the labs at numpy.org for more. Thanks for watching this video. We can create NumPy arrays with more than one dimension. This section will focus only on 2D arrays, but you can use NumPy to build arrays of much higher dimensions. In this video, we will cover the basics and array creation in 2D, indexing and slicing in 2D, and basic operations in 2D. Consider the list A. The list contains 3 nested lists, each of equal size. Each list is color-coded for simplicity. We can cast the list to a NumPy array as follows. It is helpful to visualize the NumPy array as a rectangular array. Each nested list corresponds to a different row of the matrix. We can use the attribute ndim to obtain the number of axes or dimensions referred to as the rank. The term rank does not refer to the number of linearly independent columns like a matrix. It's useful to think of ndim as the number of nested lists. The first list represents the first dimension. This list contains another set of lists. This represents the second dimension or axes. The number of lists the list contains does not have to do with the dimension, but the shape of the list. As with the 1D array, the attribute shape returns a tuple. It's helpful to use the rectangular representation as well. The first element in the tuple corresponds to the number of nested lists contained in the original list, or the number of rows in the rectangular representation, in this case 3. The second element corresponds to the size of each of the nested lists, or the number of columns in the rectangular array 0. The convention is to label this axis 0 and this axis 1 as follows. We can also use the attribute size to get the size of the array. We see there are 3 rows and 3 columns. Multiplying the number of columns and rows together, we get the total number of elements, in this case 9. Check out the labs for arrays of different shapes and other attributes. We can use rectangular brackets to access the different elements of the array. The following image demonstrates the relationship between the indexing conventions for the list like representation. The index in the first bracket corresponds to the different nested lists, each a different color. The second bracket corresponds to the index of a particular element within the nested list. Using the rectangular representation, the first index corresponds to the row index. The second index corresponds to the column index. We can also use a single bracket to access the elements as follows. Consider the following syntax. This index corresponds to the second row, and this index the third column. The value is 23. Consider this example. This index corresponds to the first row, and the second index corresponds to the first column, and a value of 11. We can also use slicing in NumPy arrays. The first index corresponds to the first row. The second index accesses the first 2 columns. Consider this example. The first index corresponds to the first 2 rows. The second index accesses the last column. We can also add arrays. The process is identical to matrix addition. Consider the matrix X. Each element is colored differently. Consider the matrix Y. Similarly, each element is colored differently. We can add the matrices. This corresponds to adding the elements in the same position, i.e. adding elements contained in the same color boxes together. The result is a new matrix that is the same size as matrix Y or X. Each element in this new matrix is the sum of the corresponding elements in X and Y. To add 2 arrays in NumPy, we define the array in this case X. Then we define the second array Y. We add the arrays. The result is identical to matrix addition. Multiplying a NumPy array by a scalar is identical to multiplying a matrix by a scalar. Consider the matrix Y. If we multiply the matrix by this scalar 2, we simply multiply every element in the matrix by 2. The result is a new matrix of the same size where each element is multiplied by 2. Consider the array Y. We first define the array. We multiply the array by a scalar as follows and assign it to the variable z. The result is a new array where each element is multiplied by 2. Multiplication of 2 arrays corresponds to an element Y's product or Hadamard product. Consider array X and array Y. Hadamard product corresponds to multiplying each of the elements in the same position, i.e. multiplying elements contained in the same color boxes together. The result is a new matrix that is the same size as matrix Y or X. Each element in this new matrix is the product of the corresponding elements in X and Y. Consider the array X and Y. We can find the products of two arrays X and Y in one line and assign it to the variable Z as follows. The result is identical to Hadamard product. We can also perform matrix multiplication with NumPy arrays. Matrix multiplication is a little more complex, but let's provide a basic overview. Consider the matrix A, where each row is a different color. Also, consider the matrix B, where each column is a different color. In linear algebra, before we multiply matrix A by matrix B, we must make sure that the number of columns in matrix A, in this case 3, is equal to the number of rows in matrix B, in this case 3. For matrix multiplication, to obtain the ith row and jth column of the new matrix, we take the dot product of the ith row of A with the jth columns of B. For the first column, first row, we take the dot product of the first row of A with the first column of B as follows. The result is 0. For the first row and the second column of the new matrix, we take the dot product of the first row of the matrix A, but this time we use the second column of matrix B. The result is 2. For the second row and the first column of the new matrix, we take the dot product of the second row of the matrix A with the first column of matrix B. The result is 0. Finally, for the second row and the second column of the new matrix, we take the dot product of the second row of the matrix A with the second column of matrix B. The result is 2. In NumPy, we can define the NumPy arrays A and B. We can perform matrix multiplication and assign it to array C. The result is the array C. It corresponds to the matrix multiplication of array A and B. There is a lot more you can do with it in NumPy. Check out numpy.org. Thanks for watching this video.
In this video, we will discuss Application Program Interfaces, or APIs for short. Specifically, we will discuss what an API is, API libraries, and REST APIs, including request and response, and an example with PyCoin Gecko. An API lets two pieces of software talk to each other. For example, you have your program, you have some data, and you have other software components. You use the API to communicate with other software via inputs and outputs. Just like a function, you don't have to know how the API works, just its inputs and outputs. Pandas is actually a set of software components, much of which are not even written in Python. You have some data, you have a set of software components. We use the Pandas API to process the data by communicating with the other software components. Let us clean up the diagram. When you create a dictionary, then create a Pandas object with the data frame constructor, in API lingo, this is an instance. The data in the dictionary is passed along to the Pandas API. You then use the data frame to communicate with the API. When you call the method head, the data frame communicates with the API displaying the first few rows of the data frame. When you call the method mean, the API will calculate the mean and return the values. REST APIs are another popular type of API. They allow you to communicate through the internet, letting you take advantage of resources like storage, access more data, artificial intelligence algorithms, and much more. The RE stands for representational, the S for state, and T for transfer. In REST APIs, your program is called the client. The API communicates with a web service you call through the internet. There is a set of rules regarding communication, input or request, and output or response. Here are some common terms. You or your code can be thought of as a client. The web service is referred to as a resource. The client finds the service via an endpoint. We will review this more in the next section. The client sends requests to the resource and the response to the client. HTTP methods are a way of transmitting data over the internet. We tell the REST APIs what to do by sending a request. The request is usually communicated via an HTTP message. The HTTP message usually contains a JSON file. This contains instructions for what operation we would like the service to perform. This operation is transmitted to the web service via the internet, and the service performs the operation. In a similar manner, the web service returns a response via an HTTP message where the information is usually returned via a JSON file, and this information is transmitted back to the client. Cryptocurrency data is excellent to use in an API because it is constantly updated and is vital to cryptocurrency trading. We will use the PyCoinGecko Python client or wrapper for the CoinGecko API, updated every minute by CoinGecko. We use the wrapper or client because it is easy to use so you can focus on the task of collecting data. We will also introduce Panda's time series functions for dealing with time series data. Using PyCoinGecko to collect data is simple. All we need is to install and import the library, then create a client object, and finally use a function to request our data. In this function, we are getting data on Bitcoin in US dollars for the past 30 days. In this case, our response is a JSON file expressed as a Python dictionary of nested lists, including price, market cap, and total volumes, which contain the Unix timestamp and the price at the time. We are only interested in price, so that is what we will select using the key price. To make things simple, we can convert our nested list to a data frame. With the column's timestamp and price, it is difficult to understand the column timestamp. We will convert it to a more readable format using the pandas function to_datetime. Using this to_datetime function, we create readable time data. The input is the timestamp column. Unit of time is set to milliseconds. We append the output to the new column date. Now we want to create a candlestick plot. To get the data for the daily candlesticks, we will group by the date to find the minimum, maximum, first, and last price of each day. Finally, we will use Plotly to create the candlestick chart and plot it. Now we can view the candlestick chart by opening the HTML file and clicking Trust HTML in the top left of the tab. It should look something like this.